Hi everyone, we might get started, even if a few stragglers come in after we've begun. All good, all good. It's with great pleasure today that I welcome people in person, still a bit of a shock to many of us, to today's conference on solar operations and asset management. My name is Tess Fitzgerald and I'm a director in KPMG Melbourne's commercial advisory and transactions team in the energy sector, and I lead the team here in Melbourne. I'd just like to start today by acknowledging that we're meeting today on the lands of the Wurundjeri people of the Kulin Nation and pay my respects to their elders past, present and emerging. Aware we've got some people dialing in from around the country, and of course respect to the elders of the lands on which they're meeting today as well. It is a real pleasure to have an in-person meeting and a topic and discussion today on something that's so important and pressing in the energy sector and that we're seeing arise again and again in our commercial advisory, and I'm sure I'm really looking forward to learning a lot from everybody here today. When reflecting on the discussion today, it occurred to me that for most of us in this room who've been in the energy sector, as I have, more than a decade, we started at a time when there was no real large-scale solar in the country. What we've seen is a real rapid evolution of that large-scale solar sector, and has seen an industry emerge from its infancy, starting to find its feet, showing a lot of resilience amongst very significant changes, constant change in the political landscape. The industry really saw a breakthrough back in 2015 when it seemed like all the pieces of the puzzle were starting to get together. We saw significant connections of Nyngan and Broken Hill solar farms being commissioned. Felt like the industry was taking off, followed up in 2016 with more wins. So then you fast forward to 2020, and today we see there are, I think it's 22 large-scale solar wind farms commissioned. And when I checked, there were over 52 projects under construction right now as we entered the year this year. So it's a really important time to have this conversation as we start to catch our breath from that rapid expansion and move into a phase of actually understanding some of the operational and asset management challenges that we're seeing in the sector. That doesn't dampen the enthusiasm, but certainly checks the reality in some of our commercial and asset management and operation understanding of how these assets work in an Australian market. With more than 4 gigawatts of large-scale solar assets now installed across the country, I don't have to tell any of you in the room today that we have seen some really particular challenges emerging around local grid conditions changing and leading to significant curtailment and market impacts, negative pricing impacts, falling spot market prices, elevated operational expenditure, and equipment failures and inability to source spare parts. Now, I'm here as a commercial advisor, and I'm really keen to learn from the expertise in the room that we have today, because we can't really separate these issues from the kind of commercial issues that we see day in, day out, working with project developers, working with corporates, looking to enter PPAs and trying to understand that financial, pros and cons and benefits of new project development. And importantly, working closely with government on some of the major projects to bring new builds into the market as well. Looking forward to hearing a great conversation today. Personally, I like a smaller room, which we have, because I think it lends itself to more of a back and forth and a dialogue, and I'm really hoping we can all get involved in that today, and I'll be calling on people for Q&A as we go on, so watch out. And I think some of the challenges I'm interested in hearing about is, well, how do we actually maximise the value of these assets? How do we unleash some potential? How do we tackle the challenges? How do you think about navigating some of the cutting O&M strategies that we hear about in the market? I think, to really take advantage of the benefit of the conversation today, I am going to ask that the moderators try to keep to time in the panel and keep their panel members to time. For moderators and keynote speakers, if you have some extra time that you leave open, that's great, because that gives us time for Q&A and really make sure that everybody in the room is able to participate there, ask their key questions, but also, if you have something you want to share from the floor as well that you think adds, I think, today's a really great time for those conversations in this room, but also outside. There's plenty of time over coffees and lunches and things. Many of you will be here tomorrow, so I won't run through all of where everything is, but we do have a coffee break coming up, and lunch will be, down the hall in a little while. I think before I hand over to our first panel and our first moderator, John, who I had the pleasure of meeting in person today after hearing his name and seeing him on Zoom over the years. Just like to sort of reflect that, I'm hoping today that these discussions, as we think about how to improve our operational assets of the plant we have today, it also really helps to inform that design and the development of the next phase. Because we know that to meet the net zero requirements that are coming down across on a state-by-state basis, to meet the corporate requirements around renewable energy, and to meet community expectations that we are moving a grid to a renewable energy future, that we really urgently as a community have to get our head around how to best manage and maximise the value of these assets. And with that in mind, I'll pass on to John to come up and introduce his panellists and his panel, and welcome the panellists to the stage. Thanks everyone for today.
Yep, test, beautiful. Good morning, everybody. So my name is John Grimes. I'm the Chief Executive of the Smart Energy Council. So we're an independent peak industry body for the smart energy space. Been around since 1954, actually one of the oldest renewable energy organisations in the world. We have over 1,000 members across the space, everything from large scale, renewable projects, wind, solar, large scale energy storage, all the way down to, behind the meter energy storage, heat pump, hot water technology, electric vehicles, and everything in between. So that's kind of the space that we play in, and really great to be here today. And a really topical area that we're talking about today, the rise and emergence of large-scale solar assets, but also a whole heap of both technical and market challenges that is facing, the space right now, as we need to shove out the big polluting generators and have plenty of capacity built so that when we turn off one engine, the clean engine, the renewable energy engine, is ready to go. The analogy that I've heard, which I quite like, is it's a bit like driving a car and changing from an internal combustion engine to an electric engine while you're driving the car, right? It's a non-trivial thing to do. So all of these things are really important. Delighted to have a really fantastic lineup of panelists, 4 panelists here with us today. And I might just pass to each of the panelists to give a quick introduction for themselves. So Stephen, first to you.
Thanks, John. Is that working? It's a bit of deja vu for me, actually. I presented at another conference, I think in this exact room, about 2 years ago, like literally 2 days after my daughter was born, and she just turned 2 the other day. So it's nice to be back at a conference and to be able to look at people face to face. I'm Stephen Challis, asset manager at Esco Pacific. Esco is primarily a utility scale solar developer. But a few years ago, we thought, I was just saying to John earlier, we were developing solar farms and investors were wanting to buy them off us, but they didn't want to operate them or asset manage them. So we also set up an asset management group to manage the assets on behalf of the investors who purchase the developments. We've currently got 500 megawatts under management, and we're building 2 additional assets next year. And then me personally, my background was oil and gas in the sort of operations and maintenance space for 5 or so years. And then in the last 4 years, I've been in the utility scale solar industry.
Tremendous. Thank you very much. Roshan.
Yep. Good morning, all. Roshan Dharmasena. I'm the head of O&M at VSol Energy. I've been in the power generation industry for like 17 years and was involved and involved in the setup and managing of RCR O&M business, well as the VSol O&M business. So at VSol, we are an owner, developer, and a construction manager, asset manager, and an operator. So we own around 400 megawatts across 6 solar farms across Australia. And by By March next year, we'll be having like a close to 800 megawatts in operation. Yeah. Over to you,
Tremendous.
John.
Excellent. Thank you. So we might now pass to Amit, who's joining us online. Amit.
Good morning, everyone. John, let me know if you can't hear me, but I'm assuming that everyone is
Loud and clear. Yeah.
Perfect. Thank you. It's always technology glitches at the wrong time. My name is Amit. I'm head of technical and EPC for FRV Australia. FRV is one of the early movers in the utility scale solar and renewable energy assets in Australia. In fact, our first utility scale plant was way back in 2011 when utility scale solar PV was completely unheard of at that time in Australia. So we've come a long way since then. By now we have more than 600 megawatts of operational or under construction assets and under construction in the very late construction stages. Expected all of those 600 megawatts will be operational in coming months, and about more than a gigawatt of pipelines ready to be developed and in various stages of development.
Tremendous. And sorry, go ahead.
And my responsibility is on the technology selections and EPC contract selections, design optimizations. I have about 11 years of experience in solar and in total about 18, 19 in technology space.
Fantastic.
I look forward to attending this session.
Yeah, welcome. Tremendous. Sarup, we might move to you next. Now, you're from a slightly different company. Can you tell us a little bit about SenseHawk?
Sure. Thank you, John. Can you hear me?
Yes, loud and clear.
Okay. So my name is Swaroop. I am a founder and the chief executive of SenseHawk. We are a software company that is building software for solar. I thought it's easiest to use analogies to let you know what we do. You can think of us as a hybrid of Google, ArcGIS, IBM Watson, and Uber. What we do is create a digital twin of solar sites right from pre-construction, where you have preliminary plans and site information, and then take that all the way through end of life, where you can walk a site with your handheld with a map of the site in your hand, click on a device and get to know everything about that device, when it was installed, how it's performing, all of the QC checklists that were created. And beyond that, we also automate a lot of the processes and workflows that go on top. And
Fantastic.
I've been in a mix of different industries. I started off building handheld devices and became a big advocate of maps-based services. I then went into semiconductors and eventually ended up in solar, where I worked on a mix of utility, off-grid, and primarily rural and solar for irrigation.
Great. Well, looking forward to hearing a bit more about the service that you offer. And finally, Alok from Jinko Solar, welcome.
Hi, good morning, guys. Do I need to switch on it so you can hear? Okay. All right. I'm from Jinko Solar. I've been with Jinko Solar for the last 5 years, done almost like 15, 20 large scale projects. And we have delivered almost close to 2 gigawatts towards end of this year in last 5 years. And we have a separate division called Rooftops, where all these rooftop installation, which was established, I think, in 2006 here. But I started this division in 2017, and we are one of a prominent module supplier in this market. We have done some fantastic cutting edge or introduced cutting edge technologies to Australia. We were the first one to introduce half cells, then mono modules, and now recently we are delivering a 500 megawatt plus solar project with 182 mm 540 plus watt modules. So and we are right now in process of introducing our N-type Neo modules, which are around 600 watt in Australia for utility projects. So this market is very exciting for us. We are one of a leading player in this industry. On my personal side, I'm a chemical engineer, work for Honeywell, DuPont, and many other organizations in my last 15, 20 years of career. And yes, I'm happy to discuss a lot of topics which are going to be concerned for our market in Australia, especially on O&M and how to manage these assets for next 30 years once you build these assets and maybe beyond that. So that's what I'm going to talk about today. Thank you.
Yeah, fantastic. Thank you. So when you're thinking about a large solar asset, you've got to weave your way through a whole lot of really difficult problems, right? There's problems inside your own control, which is technically setting up the project. There's connecting to the grid, and then there's operating in the market, right? That's an ongoing challenge, in terms of how you do that. So the first question that we've got is really, what can large-scale asset managers do to reduce cost and maximize profitability in that kind of washing machine environment of challenges? Stephen, I might pass to you first.
Yeah, thanks, John. I think it'll be good to have Roshan and I next to each other because we're going to have quite differing views because we've got really different sort of ownership models. For me, what I see, I think it reflects the industry at the moment. It's a really discrete sort of contribution to overall asset management and operations. So we've got, an equity owner, an investor, an independent asset manager, and then an operator on site, typically from 3 separate businesses. I think that will change in the future, but that's really what we see at the moment. And for me, the question around, maximizing profitability is around, focusing on revenue and the cost side. And from my point of view, the biggest contributor to both of those is the performance of the operator on site. So in the operational phase, by far your biggest OPEX cost at a solar asset is the O&M contract at site. There's insurance, there's other big costs, land management if that's outside the O&M contract, but that is by far the biggest cost. In my opinion, the biggest contributor to revenue is the performance of the operator on site. Low availability, low performance ratio, the impacts they have annually in terms of lost megawatt hours on revenue is huge. And if the operator was performing well and able to maintain availability, performance ratio, you'd realize a lot more on the revenue side. Yeah. So I think the key to understand there, John, is that given the way the industry is at the moment, they're very separate entities providing those services. You've got an equity owner who has really differing commercial incentives to an operator on site. One's an infrastructure owner and the other's providing a fee for service. So crucial that you have a really strong O&M agreement in place that aligns those commercial incentives.
I'm really keen to come back to that to talk about an O&M agreement, but Roshan, I might move on to you in terms of your views around this question.
Yeah, thanks, John. As Stefan mentioned, like when it comes to asset management, there's 2 sections. One is financial asset management, one is technical asset management. So part of the technical asset management lies on the O&M operators as a O&M responsibility that becomes like operations, maintenance, and technical part of the technical asset management. So answering to John's question, like how are we going to maximize the profits? So O&M contract, like if you look at the whole OPEX, the financial model of the solar farm, so the OPEX, like it again divides into OPEX and CAPEX. So if you look at the OPEX, the O&M contracts like around 35 to 40% of that OPEX. So as Stefan mentioned, like the other things, leases, the connection costs, and all those things, if you take them out, O&M contributes around 35% to 40%. So the first thing is like one of the reasons I joined this panel is the model is not right in Australia. So I'm just really frustrated because I'm in the owner's end now, owner's table. I used to be in the operators, the table. So the thing is like in O&M, as Stefan mentioned, you need to have a very robust O&M contract. So what he's saying is like you'll put like a lot of availability guarantees and everything, and just push the O&M contractor so hard and give less and take more. So that's not sustainable. So at the moment, if you look at O&M contracts, the more risk, the owner is not willing to take risk. They are passing that risk to the O&M contractor. So how does the O&M contractor recover that risk? They have to price it up into O&M contract. The O&M contract price goes up. So if you look at the longer term, how we want to reduce the O&M contracts, O&M pricing. So first thing you need to do is think and risk share the technique between owner and the operator. So the 50% risk, like it can happen or not happen. It might not happen. If it doesn't happen, the profit goes to the owner. So otherwise, the operator will anyhow price that risk into the O&M contract. Owner has to pay it out. So you can't talk about like reducing the pricing. So that's one of the things. And the other thing is the spare parts. So I know the test mentioned about like in high level, like the areas, the insurances cost going up, because we have seen like you can't get the spares. When the plant is down, what the owners do? They go for the business interruption, try to cover from the business interruption the insurances. But then again, next time the premiums goes up because you don't have spares. So if you look at 10, like take 20 solar farms, look at the spare parts. Every farm has the same spares. And as per the Murphy's law, every time when something goes wrong, you don't have it in the spares because everybody got the same spares. So that's something that like industry-wise, like we need to discuss, like the project basis, what are the critical spares to maintain. So that's one of the things. And the other thing is like you need to have a proper computerized maintenance management system. So we are going to touch base that in the later session so that you can do proper asset life cycle costing. So that means you don't have to keep on repairing like a inverter or a combiner box for years. So you understand, like when all these costs, everything's recorded, you can do a life cycle costing and you can make a like intelligent decision whether to replace that or repair it. So there are some of the things that I just wanted to touch base, but this we can go forever. But I would say like with these new technologies, because we need to do like a more engage in the data-driven maintenance practices rather than traditional maintenance practices. Because if you look at O&M contract, it says, okay, 5% of the solar farm, you have to do the IV curve testing. That's a very labor intensive the process. But if you want, if the O&M, if you expect O&M to do that, we have to price it. We do the time study, work study, and we price it out. But then again, you can do it in better ways. So we do it in our farms. We do the aerial thermography, and we do the combiner box level, the DC analysis monthly basis. So then we can find it. What are the underperforming combiner boxes? Then we just go to the layer by layer. We peel like an onion, and we go into the combiner box, and then we do if you can't find it, we can check all the strings. So it's an attitude in the market. So the asset owners and the asset managers and the O&M contractors, because at the moment, asset owners and the asset managers, they are very stubborn. They don't listen to the O&M contractors who are really doing the job. Asset owners, asset managements, they are sitting in an office. Like I told Tess in the morning, I call them like they are Excel ninjas. So they work on a spreadsheet. They don't realize what's happening on the site. So it's a communication, it's a discussion need to be happen and listen like what are the best methods that we can engage. So that's the only way that we can reduce the cost.
Great. Roshan, we'll need to move on, but we've actually had a bit of furious agreement so far. Actually, it's O&M costs is kind of, let's really get those down. Ahmed, I'd like to come to you now and get your view on, what's the area you can really attack to improve profitability?
I thought there was actually two aspects of the question, right? So value and profitability. And I think enough has been said about profitability. I'll say a few things about value, right? So the life cycle of utility or large scale utility scales have gone through, a phase where a lot of community has gone through difficult phases of construction and development. And now that the solar farm is operational, I think to bring wholesome value to these assets, asset managers who are actually also the owner of the stakeholder relationship, can bring value to the community, right? And that would be considered as a, doing a 360-degree value enhancement because of those assets. And by that, what I mean is, creating opportunities in the community so that they learn how to live with that asset. It's a long-term asset. Creating those job opportunities in the community, which spurs the economic activity. And through the life of these assets, and asset managers, basically manage all of these processes, can bring about a economic change in that local community. And with that, I think it's almost like a win-win situation where owners are getting their profitability and the asset is deriving the full value by bringing value to the community as well.
Excellent. A slightly different take. I appreciate that. Swaroop, we might come to you now. Really keen to get your take from a software provider, service provider perspective.
Thank you, John. And thank you, Stephen, Roshan, and Amit. You kind of gave me a segue into what I was going to talk about. So to start with what Stephen said, reduce cost, improve yields. Those are the two primary areas that we need to focus on. And I believe that software can help in both of these. In terms of improving yield, the performance analytics, predictive modeling are critical. And that is only possible if systems are, then you can create a digital equivalent of every site sitting in the system, and you can go and simulate that to figure out how you can improve performance. In terms of O&M costs, software can provide people on the ground with better information. Imagine being able to find your way around the site and get the job done, just like you land at a new city and find a restaurant with your favorite map application, right? Google or Apple. So that's really been our focus in trying to enable people to go to a new site and get up and running immediately. Now, the other part that Roshan also talked about, predictive management and intelligence for decision making on spares. Again, software can help with that. If you have a software system set up with all of the information in one place, you can then start to model performance across multiple sites and see how failures really start. And then you can apply those models from one site to another site and use this to intelligently decide when you will go out and go change a part, do a service run, or even figure out what spare parts to maintain and where to keep them, right? And again, even on a lot of the manual activities, changing to robotics, for example, IV curve testing for 5% or 10%, which used to be manual, is now done with thermal flyovers using drones. I think all of these are means to achieve the reduction in cost and the improvement in yield that we need right now.
Tremendous.
The key is a platform that supports everything.
Yep, tremendous. Alok, keen to get your view. You would supply as Jinko Solar a lot of modules to other projects, but you also build, own, and operate your own projects as well. So keen to get your view.
So very interesting views from the panel. Let me give you my take, means as a module supplier to start with. First of all, 90% of O&M activities are focused outside module. So it's about combiner boxes, trackers, inverters, connections, and all of those things. So when it comes to the real modules, and the first reaction when there is a problem is the module has degraded beyond its limits. That's a first reaction what I have seen from various IPPs. And our take is very simple there. And Roshan touched upon IV curve, EL imaging, and this whole sort of test to evaluate if the modules are performing or not. Most of them are non-standard tests. What we perform on site. A lot of module suppliers will not accept and give the warranty based on those tests. That's the first problem in this whole process. There need to be a further subsequent testing of those modules as per some of the certified labs. And a lot of people come to us with like, okay, IV testing, this is what we have done on site. But on-site testings are on-site testing, means the temperatures, the currents, and even the module itself is in good shape. We don't know. So that is where the first problem in this whole O&M setup is. And the second big issue from our point of view as a module supplier is even if you find out there is a degradation or maybe like 500 modules in this 100 megawatt solar farms are not doing well, what to do with that? We supplied those modules of like 300 watt 5 years back. We don't produce them anymore. The technology is moving so fast. So IPPs need to be a little bit more flexible on this. Like, okay, we can give you a solution. We can help you to find a solution with our latest modules, and please accept that so that you still meet your generation. So these are two topics which are very important from O&M point of view. And we're talking about like 5 years when the solar farms have been installed. Assume 30 years down the line, we don't know. We'll be doing probably 2,000 watt modules. And initially we have supplied 30 years back at 300 watt modules. How we will deal with it? The whole technology will evolve over a period of time. So maintenance of spares and all of those things, those basic due diligence need to be in place, but IPPs need to be a little bit more flexible. And that's what we as an IPP always are open and flexible to. One more minor point is usually what Roshan touched upon is the O&M budgets. So EPCs usually take 3-4 years of O&M and they budget that, and EPC pricing is very tight in this market. So they do not have enough budgets to do O&M even after DLP, which is defect liability period of 24 months. They do not do detailed testing of modules. Is there serial defect? We don't know unless it drops, the generation drops beyond the threshold limit. So these are 2-3 points I think which we need to discuss as an industry and come forward and figure it out.
2,000 kilowatt panels. That sounds great.
30 years down the line.
No, I know. I'm joking, right? So, but I have 3 panels on my house and I'll be set. You know, it's going to be fantastic. Each of you, work in a slightly different area. But is there something that you particularly is, that you're proud of that your own organisation does? Kind of the best in class in terms of getting the most out of solar assets. Stephen, I might go to you first if I can.
Yeah, sure, John. It is good. I think it's good. Everyone's got works in a different sort of segment, if you like, and has a different view. Look, for me, this one, I'd love to tell you we're using some type of machine learning algorithm or something like that, but mine's is quite rudimentary. It's just risk management. So for us, as an asset manager, really our role is really, it's communication. We're dealing with an operator on site. We're dealing with an investor. It's really around managing the exchange of information between those two entities and making sure we make the right decisions. And we do that by quantifying risk as best we can and then prioritizing that risk. So we will use something, again, rudimentary like a risk register. And that really serves to do 3 things. One, understand and quantify and prioritize the risks, both technical and commercial. Assign and develop mitigations for those risks. Make sure we really know what they are. And then third, understand when we're going to resolve those risks, have dates in mind, assign resources and make sure we're working in terms of priorities.
And contingency plans, if things occur that you can actually, you've thought about, you plan for it.
Yeah.
Great. Roshan?
Yeah, thanks, John. So in our organization, as I mentioned here, we are doing in-house asset management. And so the main things that we are doing is like getting the asset managers to the sites and understanding, like given them like a familiar, getting them familiar with the real assets that they are managing. So that opens, that makes our conversation with the asset managers much easier. So we can convince them. And when they say us instruct us to do something, so they know that it's just like a cut and paste million times. Like if it is a 1 minute here, if you try to do the whole plant, it's like a few days. So that's one of the things that we are educating our asset managers in-house. And the other thing is, so we are developing in-house, like we have a asset-centric computerized CMMS system, asset-centric computerized maintenance management system. So what we developed in-house. So what we are trying to do is all our assets, like for an example, if you take solar plant A, every asset up to the string level inside that the CMMS system. So when we create a work order like a preventative maintenance, corrective maintenance, or that's all married into that particular asset. So after a certain time, the asset managers can see what's like how much we have spent on that asset, like what's the mean time for failure of that asset. So so that's we are just going in the path, like I'm just not going to say that it's ISO 55000, but that we are going in that path. So we need to have a more intelligence asset-centric, I call it CMMS system, but some people, like when you integrate, can be a ERP, enterprise resource planning tool. So that like in traditional way, like it was the O&M contractor do the work, they report to the asset manager reports to the owner, so like that's a chain. So what we are trying to do is like a more modern concept. Like we have this the asset-centric system, and everybody has that access in a different level. So they can all see the like how the assets performing. So they can do then it is tied up to a analytical tool, like a monitoring platform, monitoring tool, how the assets doing. So I know that most of the solar farms, they have their own monitoring system. And that is like all like if that can be integrated into that asset CMMS system, that's where you get the value. And the third part is the optimization tool. So like that's where like traditionally, like for an example, you say like I think you guys all are familiar in a normal car. So you just like every 10,000 hours change the filter, change the oil. But if you look at a new BMW or anything, so what happens is, so you don't have those intervals. So when the time comes, it'll pop up in the dash screen. Okay, now it's time to do the oil change. So that is like we can optimize the maintenance based on the data that we capture from that system. So it's moving away from the traditional approach to a more modern data-driven approach. So those are the things that we are developing in-house. Like I think that's in the future, if you want to reduce the cost down. So these are all interrelated, all the topics that we are going to talk. But that's the way that you should go. Like if you're developing an asset management system in your organizations, that's where you should go. Like you start with the CMMS system, try to get those links connected, monitoring your plant, feeding into it, and have an optimization tool. And as Stefan mentioned, the risk assessment, that's separately. So like if you can create that environment in a one place, I know that's the ERP is the word for that, but they are very expensive. But like if you can do it somehow, I think that's the way. So that's what we are like VSOL is moving towards that. So we have already done the first part. So now I'm just trying to get our asset managers a bit of a taste of the system as well.
Yep. Thank you,
Thanks,
Roshan. Thank you. Ahmed.
Yeah, thanks, John. So I think it's a very, very interesting topic. The context here at the moment for utility scale solar is asset management is actually playing a catch up, right? If you look at it, the rules on the connections, the GPS processes, the maintaining that GPS is ever changing, and it keeps the asset managers on their toes, right? So obviously you need to do a best in class catch up, which I think we are doing a great job. Every other day they face with the new problems in terms of new requirements, unknown costs coming up, like cost of pays and all that stuff. So that's something which keeps them on their toes. But we need to be future looking in terms of what best in class we should do. I think what we are currently building is a very robust information management system, which will entail stuff which Roshan also has mentioned, basically capturing data and analyzing it in such a way that it can be used both upstream and downstream effectively and help us draw conclusions and take decisions. Another important aspect which has come up very recently and has taken a lot of attention, this AESCF framework, which is Australian Energy Sector Cybersecurity Framework. A lot of attention has come up on there, and we need to be able to build our systems to be complying with that framework. not just a compliance, it's just a best-in-class practice to protect your portfolio from cyber crimes, and obviously it's an asset which is connected to the grid and can have a very long-term and very deep impacts if someone fiddles with it, and that's certainly a big focus for us. And at the end of the day, I think our aspiration would be to collect all this data in such a fashion that the stuff like mean time between failures, the failure rates can be looked at, analyzed, compared between different vendors, different technologies, and we can understand what technology performs better than the other, which vendor is better than the other. So that's more of an aspiration, but certainly a best in class that we would like to achieve.
Tremendous. And Alok, I might come to you just finally on this question. It's keen to get your views.
Okay, thanks, John. So very interesting take by Roshan and Amit on this topic. What I have realized is when we see a problem in a solar farm, there are too many softwares working in parallel. So we have like a SCADA system, we have like tracker system, we have a weather forecasting systems, and all of them are talking very efficiently to each other. But when it comes to O&M, like what triggers the O&M is like, and usually that's like generation drop. There is nothing else. The string level data and all of those data are still available. A lot of these SCADA systems are also evolving over a period of time. This is digital era, and people are now getting into next generation systems. And I can vouch for it because I'm an ex-Honeywell and I've seen those SCADA systems which people are working on. And what Amit talked about is on the cybersecurity, there are a lot of integrations because a lot of these SCADA systems run in refinery and coals and airports, and also they have that capability, but it will eventually drill down to solar as well. And asset managers have to pay probably a little more to comply with that. But that's very important. But coming back to that topic, there is too much data available with IPPs, but there are not enough tools to interpret that data to a string level so that we can identify the real problem at string level in O&M systems at this point of time. And that is where we have a lot of problem. We run drones on thermal imaging. We map up to the module level. Okay, this module is having a problem because there is a hotspot, or there are technologies coming from UNSW about photoluminescence. They say, okay, we can click a picture of a whole string and can tell you where are those eels, cracks, micro cracks getting developed. There are technologies from trackers which talks about, okay, in this particular string, these are having non-performing modules because of these issues, or whatever is happening inside those strings. I think we are evolving. Probably in a couple of more years, we will have more advanced tools to probably narrow it down to those levels. I have came across a couple of more technologies in this area where actually it's like auto mapping. So your original ELs are stored at some database, and your thermal imagers take the pictures, and even photoluminescence guys can take the picture, and those can be mapped through AI within defined limits, which modules are developing. Probably we'll get there. Means although we are catching up as pyramid, but yes, we'll get there sooner or later.
And John, just
now
wanted to add, I know I did not want to take this question, but if you permit, I'd like to
of
add,
course,
add
please.
a bit. Yeah. So I mean, hearing all the discussions, I was happy because this is one of the areas that we've been working on in bringing information for a site together in one place, and then going from using that information to create workflows for individuals that might be on site or individuals that might be managing the site. For example, Roshan talked about orientation for asset manager. We can provide virtual orientation. They can zoom in just like you do on Google Maps. You can zoom in and see the site, get a sense of what the site is. And if you send a new tech to site, I mean, we've been successful in going from having them learn the site for 2 days to being instantly able to go and do something. It's like you see a map behind me. It's exactly how somebody that is on site sees. They see themselves on the map, see all the tasks they need to do, get to the task, click on the task, they get all the information, all the files they need to complete the task. And if they don't know something, they can start chatting, create a channel right within that task and start chatting with somebody back in the office. And somebody back in the office can add other people. And so you can go in and add all the different layers, the asset owners, the O&M, and the business asset managers and the technical asset managers on the same portal. Each of them can use their own nomenclature, but still talk to each other without seamlessly. So that's one thing that we've enabled, and I think that's what I'm really happy about being able to provide.
Right. So getting the Excel spreadsheet guys talking to the field guys and resolving things. Yeah, no, exactly. I think that's great. Hey, we're running short on time, and I'm really keen, we've set up, so we're really keen to get a sort of a vision statement from each of you in terms of just fairly short 2 minutes, just in terms of what you see the future. We do have time for one final question, but we'll probably limit it to just strictly 60 seconds each if we can to get through the time. And the question that we'll go to now is really that handover from EPC to O&M managers. What are the things to consider to get that process right? Stephen?
Do a spares stock take. Seems to always be retrospective arguments around what was and wasn't in spares. And then I think if you can have a extended parallel handover period, so instead of doing a two-day handover, have both operators working in parallel at the same time, if that's possible, and then update all the site-based documents and then the corporate documents. So, emergency management plans to HV switching plans, which are typically not asset plans, but corporate plans that sit with the operator, update them to reflect the asset prior to or as soon as commencing operations.
Excellent. Roshan?
Yeah, I can list everything in the mobilization process, but the elephant in the room is most of the projects are not designed to operate. So we need to start from there, like during the EPC design stage. So because there's a huge disconnect between the EPC and the operator. So the EPC designed the project and construct, and they just wanted to get out. And when the poor operator comes to the site, bloody hell, it's like systems are not in the usable manner. The SCADA systems, monitoring systems, and so there's a huge disconnect. The first thing we need to address is during the design stage, you need to get the O&M expertise into the design review meetings and design the plan to operate, so not to exhibit. So it's an operational plant. So we have taken so many plants on board, and every day we are going through these discussions, and like our punch list and the defect list is bigger than the mobilization list, that the documents we wanted. So I think that's where we need to start with initially.
Excellent. Ahmed?
I'll be quick. I think a extended overlap during the takeover process and budget for that cost. And secondly, make sure that the stakeholders relationship are also handed over, and the PPAs, the connections, the community, the banks, and everyone. So that stakeholder relationship handover is a critical aspect as well.
Saru?
Yeah, in my view, I think the way the process should be is just create a new login and pass on ownership of an asset on a platform to somebody else. And with that, they should be able to get all the information. That's the ideal case. We're not there yet, but the key is to work towards that goal, where there is either an interoperability standard that lets everyone put in data together in a format that you can then just pass on to somebody else, and they can take over, get all the information they need, right from contracts and documents to checklists to quality documents, everything they need to get the site up and running and take it over from there. If they can get that with just one field change in a IT system, that'll be ideal.
Yep. And Alok?
Yeah, very interesting topic. Means this handover, whenever happens, whether you are selling a solar asset or from EPC to O&M asset managers or IPPs, when they take over, nobody wants to take liability. But eventually what we have to do is we have to check the major parts means three key parts, which is your modules, inverters, and trackers. If they are in reasonably good position, that's the best handover which we can do. There are huge amount of cables and all of those issues may come in. But yeah, it's a fairly robust process I've seen in Australia. Means people talk, sit in a conference room and resolve those issues. And this is a big asset. Means there are on a 100 megawatt basis, there are quite a number of modules, pretty big area. You can never be like, this is ideal case scenario. There will always be a problems, but yes, that's how it is. But eventually it performs. So I don't see too many challenges there, but yes, they can be resolved. That's what it is.
I've learned a lot in this process. I've really enjoyed the discussion. Thank you. I'd like to really close on a bit of a future-looking statement. Get a sense of from each of you. In any, take the question any way you want to, but what do you see as the future for large-scale solar asset management, Stephen?
I think solar is going to be like the Carlton draft of the energy industry, cheap and ubiquitous. I think it's going to do most of the legwork in terms of producing energy, albeit it probably won't be directly grid connected. It'll be producing the cheapest energy for a big load or for an electrolyzer. Everyone's talking about hydrogen at the moment, something like that, versus a directly grid connected asset, which is sending energy to the grid at the time of day when sadly we're just not going to need it.
Right, fantastic. Roshan?
Yeah, as Tess mentioned earlier, like we have a very young market and it has grown rapidly within last 3 to 4 years. So if the market attitude towards EPC and O&M, so you guys know that how many EPCs left Australia, and if that attitude won't change, if the owners won't come discuss them in like a proper manner, I'm really concerned for the solar future for Australia, and I hope I'm wrong.
Excellent. Ahmed?
What I would like to see future evolving into is a whole environment and business for recycling and refurbishment. Right, as assets age, there will be a significant need for those services. If something cannot be recycled or refurbished, figure out a way how to dispose it off. If it can be, then develop science, technology, and methods to recycle and refurbish so that you can continue with that asset, maybe even a revived asset, right? Almost like a secondary market for automobile industry, which is so prevalent everywhere. I think that would be a very good development for this market. Second, I think would be very interesting. We are seeing some movement on that is load matching requirements and corporate PPAs. And I think that keeps asset management even busier, and for all the good reasons. It will allow another environment of software developments which will do this analytics of load matching and generation matching very well. It just creates a whole new environment for this industry, and certainly things are moving on that. A little bit, few years away, we will see more of such PPAs in the market. Keeping fingers crossed.
Excellent. Sarup. Sarup, we've just lost your audio there.
Can you hear me now?
Yes, perfect.
Sorry. Yeah, I see, two different things happening. One on the hardware and the technology side is more standardization, more assembly line processes. Every solar farm is going to be like every other solar farm. So the variability and the difficulty in managing multiple different types of assets in your fleet are going to go away. On the other side, on the generation and the grid interface side, I see a move towards what I would term as Internet of Power. Today, power is primarily generated at one end, and then consumers are at the other end, and there are these load dispatch centers that dispatch power from generating centers to loads. What's going to happen is this is going to become an internet where every load will seek for power when it needs it, and that request is going to go to multiple generators, and one of the generators is going to pick it up and dispatch that power. And that'll also need a lot of AI, a lot of additional infrastructure. But that really, I think, is the future.
Excellent. Alok.
A very interesting topic for me from forward-looking point of view. One topic which Amit touched upon is how we can extend the life of solar farm and eventually go into recycling of these modules. There are a lot of work going on there, and a couple of companies came up on recycling, got ARENA funding, and they're working on it. But my point is, in place of going for recycling, can we run a solar farm from 30 years design life to 50 years? And is there a way to do it? And that's what the next generation research is going on. If there are modules which have degraded, is there a way we can do something to them on site and make them work? So that's a topic number one, which will evolve over a period of time. And this is a topic worldwide. Jinko runs a program in US where we refurbish and recycle and repurpose and do all of those things in US. Probably we'll get that in Australia at right point of time, because still solar farms are too young in Australia. Other topic which I will talk about on software side is what we are seeing is still means a lot of IPPs are developing their own softwares to run the solar farms O&M. But I believe in next 4 or 5 years down the line, there will be specialized O&M companies like what Swaroop is talking about. They will use a lot of AI. They will integrate with big guys like Fraunhofer, TÜVs of this world, and integrate along with probably module suppliers that how you can, means right now they're throwing data to asset managers. Next generation, they will throw data to module suppliers or inverters or trackers and say, this is not working, go and fix it. Something like that. So that's what we are hoping in short term, in next 5 years time frame, and probably in next 20, 30 years time frame, we have to think through how we can extend the life of the solar farms. So these are two forward-looking statements which we would like to make at this forum.
Excellent. Tess, at the beginning of the day, you encouraged that sort of the interaction with the audience. I feel I've let you down in this session because we've run out of time for that. But I know that the 3 panel members here with us, you'll be around for a little while. You'll be here over morning tea and lunch later in the day. And so reach out if you've got questions. If this has stimulated interest for you, really take the opportunity to reach out. For our 2 panelists online, either contact me or the organizers. We can put you in touch. I think, Swaroop, you're joining us from the west coast of the US
That
today.
is correct.
Yeah, so you know, interesting software company, you know, interesting, and Amit as well, you know, so we can certainly put you in touch. So I really encourage for this not to be the end of that discussion, but the start of it. Really, I want to thank all of our speakers today. I learned a tremendous amount. It was really fabulous. Please join me in welcoming and thanking the speakers today. Thanks very much.
Thank you, John.
Thank you, John. Thanks, everyone.
And Jess, I'll pass back to you.
It's John. And if I ask the panelists to take a seat, I'm going to ask John to stay put for a moment. So thanks very much, panelists. Now, John, I thought you got off quite lightly by just getting to ask questions. So I just thought I'd borrow you for a minute.
Thanks, Amit and Swaroop. I'll get you guys.
You obviously have the great
turn your
advantage of
microphones and
speaking to a lot of
cameras
people
off,
across
because we just need to really
industry in this
quickly,
renewable space, and I'm sure
Tess
solar comes
Jefferson
up
and get
very
ready to go.
frequently. and
You
some of the
guys did
challenges we've
great.
heard
Thank you
about.
so much.
Interested if you would like to reflect for yourself on what your vision is, what thinking about it as an industry as a whole, how you
Jefferson,
see,
I can get
you know, a future
to
state
unmute
where some
yourself
of these
and
challenges
turn
are behind
your camera
us,
on, perfect.
and yeah, invite
And
you
can I
to
get
comment on your own vision statement.
Well, it's been interesting. You know, we've had
Can I just
lack of consensus around a transition plan. And when transitions happen and they're not
can I just get you
coordinated,
to share
are
your
chaotic
screen as well,
and they are
please?
expensive. And so this has been just a real, I think, detriment to the Australian
This will be my pop-ups.
experience. What we're seeing is that the
Amazing.
states and territories are going their own way. Actually, the
Okay.
the
And
pressure
did you
in
just
the
want to double
decision
check
making,
flicking
the
through your
planning, and the
slides
energy
for me?
market, because
Yep.
of the recalcitrance
Perfect. We can hear you
of the federal
perfectly,
government to
and you sound
actually set
great.
out
So
a
if you want to
plan
go to
means that the
back
states
to the
are
start
saying,
of your
well, we're just
slide,
doing
we'll
it
let
anyway. So
the
they're
team in
setting
the
their
room
own targets.
we'll let the team in
They're
the room
putting in
know that
place
you're
their
ready
own
to go,
renewable
and
energy
we'll pop you up
zones.
on screen
They're
real
putting in
soon.
place their own incentive
Okay,
program,
let's go.
and they're just getting on
Thank
and doing it. And that's because the market has spoken. It's economics, stupid, right? As Bill Clinton once famously said. And I think that's right, you know. So that's one thing that's kind of really interesting. It's a bit like, what do they say? I think the analogy is not correct, but King Canute, commanding the tide not to come in, right? Is kind of that, that this is overwhelming. But so that's been at the center of this thing, and it's just been so disappointing, because we have the innovation, the resource, the finance, the engineering expertise, and the support of the Australian people to really transition in a really exciting way and demonstrate to the whole. The second point is that consumers are just doing it, right? And so not just at a large level, but at a micro level as well. And watch out for electric vehicles. This decade to 2030, everything changes, man. Everything changes, and it's going to be a lot of fun. And smart service providers can extract value from that. And thirdly, because we don't have a vision for renewables and for our clean energy future, I think we're missing huge export opportunities. I think Australia really does have the potential to become a renewable energy exporting superpower, right? You think about the elements we need, right? We've got in the Pilbara and north of Queensland land that you can't give away, right? And we've got so much land. We've got some of the best solar and wind resources in the world, right? Put a solar panel in Germany, put one in the Pilbara. The one in Pilbara, it's not a 30% difference. It's like 260 times more energy from the one in parts of Australia. So this is a huge economic competitive advantage for Australia. We have existing export relationships with places like, Japan and South Korea and China and other places, that we've been a really good partner in supplying energy for a long time. So all the elements are there to make it happen. So
yeah, really interesting. Thanks for your comments there, John. And if I could just reflect what I found fascinating about that talk and about your comments just then is that a lot of these issues that we're now hearing about, so the supply chain challenges of small parts, that is perhaps something you think we could tackle on a national level. But what we are seeing is individual jurisdictions now really thinking about, well, what are the supply chain challenges within my jurisdiction? And looking at that from quite a localized Victorian perspective or a Queensland perspective or a New South Wales perspective. So I think certainly these issues, even in an O&M context, continue to sort of play out, whether it's a state trying to tackle it. But I think also to your slightly negative, tone, when those of us in the industry obviously are very familiar with these challenges, I was really heartened to hear just still that exciting pipeline of work coming through, that continued pressure around digitisation that we hear so much about. So do you think that there's cause for optimism?
There is absolutely cause for optimism. And the good news is that this will happen anyway. And actually, it's unstoppable. So that's the optimistic part. It's just frustrating when we could do it faster and better and cheaper.
It is. I think in future conferences, we should all have like a yoga break or something in the middle of the day just to kind of acknowledge our frustrations and keep persisting. Now, I think we've managed a sound check during that time. We're ready to go. Fantastic. Thanks so much, John.
Excellent. Thanks.
And I'd like to welcome our next virtual speaker to deliver a keynote, Jefferson Ju. And I'll ask you, Jefferson, to introduce yourself briefly at the outset. But Jefferson's is an engineer specialising in renewable energy. He's going to present to us today on solar supplied high current PV solutions for C&I applications here in Australia. I believe Jefferson's been practicing in this space for about 3 years, which is about a particularly long time, given the industry has really only been taking off in about the last 5 years. So he's got a good deal of history to give us in that context. And Jefferson, we're excited to hear about this today. Thank you.
Yeah, hi. Hi, everyone. Can you guys hear me? Okay, I think it should be good. So, hi, everyone. Sorry, I can't be in Melbourne for this week. And but today, I think I'm going to present our Solis brand, our company profile, and some interesting information. And I think here we go start. So mainly have 3 points for my presentation today. First is our company profile, so who we are, what we do. And the second will be our commercial and utility side solution. And the last part will be our solar reliability. So I think this is the most important. So mainly for the commercial or utility sides, we don't want our system installed today, but fail tomorrow. So first part of our history, so who we are. Solis company, we have focused on string inverter for 16 years. Our company established in 2005, and we are one of the most experienced and largest manufacturer of solar inverters. And in 2009, we have completed new PV inverter production facility that including entire industry. And in 2010, our Australian office has established, and we start our business by cooperating with AGL. And in 2015, our equipment is installed at Eiffel Towers. I didn't achieve by any other manufacturer. And we are the only company in China to receive the award for the EUPD of the PV inverters for, sorry, it shall be 6 consecutive years. It's a typo here. It's from 2016 and to 2021, so this year. And we are also the first published company with a primary focus on the string inverter in 2019. And the 2020 is our 15th anniversary. And the good news is, although with the COVID impact, our second manufacturer base will put into operation in 2021. And it will help our delivery capacity to reach 4 gigawatts. So company profile. So we have over $457 million of the asset. We have over 2,000 global employees and over 300 engineers in the R&D team. So no matter what kind of the customer demand, what kind of system requirement you guys facing, give us a know, and we have the engineer can support that. Financially, we have 0 bank debit. So this is quite good because it's like a fully controlled by our own financially. And for the financial report in 2021 with the COVID impact also, but we still have the sales is increased almost $233 million US dollars. And we have the increase compared last year is 99.8% increase. So this is quite huge. And also here is a graph for our sales part. You can see just like our sales is growing. So that's all for our history and our asset. So now I'm going to introduce our commercial and utility side solutions. So first one, it will be our 3-phase 25 kilowatts to 40 and 80 to 110 kilowatt series. So first, 25-40. So compared to other inverters in the market, our inverters is normally have the smaller size, lightweight, and also for the DC input current, voltage range and the MPPT numbers, it will also be our advantage. So for this one, we have the maximum input current is 13 amps, and the DC to AC oversize is 1.3, but it need to follow the 0.75 rules. It has 4 MPPT designs, and the maximum efficiency is 98.8%. And also have the string level monitoring, remote upgrade, integrated IV string scan, 24 hours consumption monitoring. This is our quite standard package right now already. And the reliability is have the natural fanless design for the cooling part, and the optional anti-PID function. And they also have the both AC and DC for the type 2 SPD, and the optional AFCI for the Australian market, and also for the fuel-less design. And for the 80 to 110 kilowatts 3-phase inverters, maximum input current is also 13 amps. Also, it depends on the size. It can be a 9 or 10 MPPT designs, and the maximum efficiency is 99%. It's better than the previous one. And also, same as the previous one, we have string level monitoring, remote upgrade, integrated IV string scan. And for reliability, we have the also it's almost exactly same as the previous one because it's the same series, just like the size. As mentioned, for all our inverters, it have the smaller size and lightweight, so it will be much easier for the installation. So for the general commercial and utility storage scenarios with our 5th generation smart inverters, this is our 5th generation, and it can more flexible to the design because even if it will be compatible with our old inverters, it can be connection in the series, parallel. So it will be, no matter which number you are going to want to achieve, you can use our inverters to do it. Also for the monitoring, this is quite important for the commercial job. Monitoring solutions with data logger. This is the standard data logger with Wi-Fi connection is included in the packing, and also it will be have another way to do it, which I will introduce later. First, it will be use a data logger, which including the packing and just like a connection to the internet, and can send the data to the monitoring. Second, also for the data logger, we have the LAN data logger or the GPRS data logger, just like for different kind of scenarios. But for this one, you need to do the settings one by one. So all the inverters need to set to a setting once. But if you have another scenario, is like you have multiple inverters at one side, and it will be easier if you want to use the RS-485 cable to communication between the inverters, and you can choose our monitoring box. Monitoring box is like you use a cable to connection the box and the inverter, all the inverters. Then it can use either Wi-Fi or GPRS to send the data to the internet. So for this one, the advantage is that you only need to do all the setting once, but you need to make sure all the inverters have the communication cable wiring between them. Also, we have another solution is like a PLC, which is optional one. It's much cheaper and can be easier to be achieved. And the inverter integrated communication board generating PLC signal, and PLC can just like convert to RS-485, then do the communication. This is just like a different way to do the communication. Also for the cost saving solutions, for just like to save some money, our inverters can support 2-in-1 Y connectors. Use the Y connectors to combine 2 strings connect to 1 input of the inverter. It can save some money to the DC cables. And also, just like for another saving part, it will be the element cables. You can choose, our inverter supports the AC element cables. Use the element cable on the AC side to save for the AC cabling. And in the future, if you have any questions regarding to the details about this part, give us a call, and we are always willing to help. And another second part, next part, it will be another important part. It will be the XY limitation and the consumption monitoring. Because I think currently there is a lot of requests for this one. For our 25 or to 41, it supports the consumption monitoring and the XY limitation. But for our 80 to 110 kilowatts, it only supports the XY limitation currently. And to achieve that, if you have only single Y unit, you only require to have our meter to install with the inverter. And of course, it needs to do some settings on the inverter. But all the cables between the inverter and the meter is a pre-made COM cable. You just plug in and play. It will be much easier for the installation. So, and then if we have the multiple units at one site, sometimes it will be a little bit complicated. And for example, you have 125, 140, but you need to achieve like 0 export limitation or even some weird number. You can choose our EPM, X-Power Manager, which is an external one. And we have for different kind of scenarios, we have different size. And for this one, you just use the RS-485 cable to communicate, to wiring them together, to have just like the wiring chain together. Then use a CT connection to the EPM. Then you can set the number which one you want to achieve. So the EPM will control all the units to achieve the XY limitation. So also for most commercial job, it's very important for the PID recovery. It can automatically start when the PV integrator is low at night or at like early of the morning. It's our building solutions. it will be recover the decoration. It will be just like have the better performance. And also for the commercial job, the most important is for the AFCI function, because typically for the commercial job is a rooftop system. Factory, lab, office are often high value assets at the right below of the PV panels. So potentially the fire risk will not only affect the PV system itself, it also will have some additional damage because it have the asset below the panels. The higher DC voltage and the system plus the nearest DC connection, and any damage, any accident happen, it will be cause a DC arc fault or to lead to fire. So our inverters have the FCI function built in, and FCI is full name is arc fault circle interruption. So it will be notice there is an arc fault, and it will be cut the circle and stop the fire, just all the damage just right there. Okay, so that's all the functions, but also a good news is we have for this year, 2021 June or July, we have our whole own designed monitoring system. It's ready to use, named Solace Cloud. They have a lot of new function building, and it looks much neater and much clearer than compared to before. And they can support the remote upgrade, remote power on off, remote to modify the grid country code, and for string level monitoring, and also for the IV string scan. So, and it's also very easy to use. If you have our existing customer, you already have our monitoring account, just like a simple data migration will be can be achieved. But if you are a new customer, just register account and much easier to use. Okay, here is the last part of my presentation is the reliability. I think this is the most important because the reliability is we want our inverters to last as long as we can. So first, I think the most visual part for the reliability is our R&D expansion. So our R&D expansion is increased year by year. 2021 compared to 2020 is increased almost 99%. We have increased 5.2 million more USD dollars we spend on the R&D expansion. And here is some photos for our second manufacturing line. You can see it's very clean. Everyone wearing hat, wearing jacket. We want to build a dust-free, and we guarantee 100% unit is tested before the dispatch from our factory. Also, our inverters is tested by the third-party DNV-GL. It's a top of the range lifespan project in the string inverter category. And after their test, they can prove our inverter have 25 years lifespan. So this is a really, really long time, and I think it is, and this is tested by we have the certificate with that. Just in the future, if you are interested, give us a call. We can share the certificate with you. Also, here is our global service map. We have just like a branch around the world: US, Indonesia, Turkey, Spanish, and Australia in 2010. And in the future, if you got any questions, always welcome to give us a call. And here is our contact info. And we have the warehouse and service team located in Melbourne. So it's a local service team. And yeah, so that's all for my presentation today. Thanks, everyone.
Thanks very much, Jefferson. We are out of time, so I think your invitation for follow-up questions is a great one to the audience today. I don't know about everybody else, but I'm one coffee short of my normal allowance by this time in the morning, so I think it's a good time now for us to take advantage of the coffee break and stretch legs and come back here for a really engaging next session in when are we starting again? 11. Thanks, everyone.
Thanks, Jefferson. You did a really great job. We're heading off to break in the room.
Okay, thanks.
Thank you. Have a great day.
You too.
Hi, Greg. My name's Zoe. I'm just at the convention centre. So I'll be a person on site looking after the Zoom call.
Okay, great.
Awesome.
Thank you.
Yeah, your camera looks perfect. Can I get you to just chat a little more for me? Just
Yeah,
tell me
sure.
where you're calling in from, how your day's
Yes.
going.
I'm actually not going too badly. So, yeah, thanks for making this happen. Apologies I couldn't be there in person, but I'm sort of backwards and forwards in a number of places today. So, but yeah, looking forward to the session. And I spoke to Dawson this morning as well, so it should be good.
Awesome. I can hear you nice and clearly. Like I said, your camera looks great. So we are going to start this next session is supposed to start now with a 20-minute keynote, and then the panel that you're in is supposed to start at about 20 past. It looks like we're running maybe a couple of minutes behind, but I will just communicate to you in the chat that will be coming from MCEC PPT. It's just I've got 2 Zoom sessions open here. So I'll let you know when we're wrapping up and about to put you on screen ready for your panel.
Okay, and can I just clarify, how many people are actually in physical attendance there?
In your panel or overall?
Or just today, like,
Today, yep. It kind of varies because they're all out at morning tea. I think there's probably maybe been about 50 people in person.
Okay, so there will be people in the room, but
oh yeah, 100%, yeah, there's quite a few.
But
people.
the majority be online. Is that the way it'll be?
I'm not really sure, as I'm just looking after the Zoom element, and then I've got another technician with me who we're just doing the in the room stuff. Yeah, online I'm not 100% sure about, unfortunately.
That's okay. All right. Well, no worries. I'll stay on, and I guess you're ready when you're ready.
Yeah, perfect.
Thank you.
everyone. Well, hope you've enjoyed the slightly extended coffee break there. And I know personally I had the opportunity for some great chat, so it was hard to pull myself back, but really excited about the next session. I'd like to start off with by introducing our next keynote speaker, Andrew Gilhooly. Andrew leads Trina Solar's APAC Trina Pro business and has over 12-year experience in this market across not only Australia, but Asia and Europe as well. So I'm sure he'll have a lot of insights for us today in his presentation on lowering risk and cost for utility scale solar projects in Australia. I'm just going to encourage everyone to take a seat before Andrew starts talking. So Andrew, I'm going to welcome you up here. Thank you very much, Andrew.
Well, good morning, everyone. Pleasure to be here today. What a year. Great to see so many familiar faces in the crowd. I'd like to start today by acknowledging the traditional owners of the land from which we're meeting today, the Wurundjeri people, and I pay my respects to their elders past, present, and emerging. So we'll just talk today about lowering risk and LCOE for utility projects, some insights that we've seen in Australia. But before we do that, we'll just set the context for Trina and Trina's involvement in the tracker business. So a couple of years ago, Trina acquired a controlling stake in a Spanish tracker company called Enclave. Back in 2020, they increased that equity position to 100%. So the tracker business is now a wholly owned subsidiary of Trina, the Trina Solar parent company. We have a global footprint. The deployment track record is now in excess of 7 gigawatts with local production centers in most of the major continents, including in India and ongoing in Australia also. So we'll just set the scene for what the end game is really, and it's all about reducing LCOE, right? So it's the same story globally. Precipitous declines in LCOE in pretty much every key market, some super low bid pricing in the Middle East, approaching this mythical $15 per megawatt hour target. Not quite to the same level in India, but super aggressive, and that stimulated a lot of engagement from the IPPs in India, where they're now considering trackers and seeing trackers as the best opportunity to attain the super low bid pricing and yet remain profitable. And there's a study there that from Ceres out of Singapore, basically corroborating that the combination of bifacial and single axis tracking is really unlocking the lowest LCOE in every major market globally. So I probably don't need to inform you, anybody in this room, about the challenges in Australia. There's congestion, curtailment, negative pricing risk. There's uncertainty from the financiers about possibly government intervention, stranded assets, and so forth. That's manifested in the decline in projects reaching financial close that we've seen over the past few quarters, and commodity price rising. Basically anything with an S, silicon, steel, shipping, to somewhat less an extent the steel, that seems to have moderated somewhat, but very, very challenging on utility projects, which tend to be more sensitive to these component prices. But there's an incredible opportunity remaining. This is a chart from Rystad. We're seeing cumulative additions year on year between the 15 to 20 gigawatt mark. And what I'm showing here is we quoted 0.5 gigawatt in the LSS4 program in Malaysia over the past year. And I just wanted to compare some insights from that market to here. Obviously, Peninsular Malaysia, high population density, pretty prohibitive cost of land. Land is very hard to come by. So what we found when we ran the numbers on LCOE, including cost of land acquisition, either leasing or acquiring, we found that actually compressing the rows of the solar structures into a more compact form factor, thereby using less land, was unlocking the lowest LCOE. You get a bit more shading loss and a bit more of a erosion in your energy through more time spent in backtracking and so forth. But completely of a different story in Australia, right? It's a huge country, vast expanse of free land, at least, and you know, relatively low acquisition cost, at least outside of the main population centres. So what we find in Australia is the lowest cost of energy. No surprise here, it's at a much wider GCR, as we call it. However, deploying trackers at these wider GCRs increases the amount of land that we have to use. And if you use more land, you basically increase your construction risk, either from a geotech or a topography risk. And certainly what we're seeing at Trina is sites becoming increasingly more challenging. You know, a lot, if not all of the low-hanging fruit has gone. We're now seeing sites with highly irregular boundaries. The days of these nice uniform four-corner arrays are well and truly behind us. So it's important to choose tracker technology that can fill the nooks and crannies of these sites and attain a high land utilization and plant capacity. You know, there's a historic perception that trackers could only be deployed on completely flat sites. That's now no longer the case, including with Trina. We have a patented bearing technology where we can unlock these previously unviable sites from a terrain perspective. Strong wind regions, we're seeing trackers included in our own tracker technology being deployed into cyclonic regions now. And obviously tracker structures being more susceptible to wind, especially as the modules have got larger and larger, very, very important to verify the wind performance. Also soil, you know, Australia is a pretty harsh country, and we're seeing, especially in Australia, lots of sites with a high prevalence of rock where we're having to pre-drill a high proportion of the foundations, possibly backfilling with concrete. On the other end of the scale, the New Zealand market's just gone nuts. You know, I can't believe that I'm standing here today and we've got hundreds of megawatts in the pipeline for that particular market. And it's completely different over there, where we're seeing sites typically having cohesive less soil, where we're having to embed the piles sometimes as deep as 3 to 4 meters. So if you can choose a tracker that reduces the number of foundations, that can mitigate that cost penalty quite considerably. I'm also seeing some sites going ahead that are prone to flood inundations. So we have two different types of tracker that cater to all of these different site conditions, a 2-portrait single row tracker and a 1-portrait dual row. I'll just focus on the 2-portrait first, so the 1-portrait, sorry. So we use a slew drive gearbox, which only motorizes 50% of the rows. And we use a rotating mechanical shaft with universal cardan joints to unlock a superior slope tolerance. Even though the rows are linked, we can still deploy this tracker on pretty uneven sites. We use spherical bearings, so we can also deploy the site on sites that have highly uneven terrain. We've optimized the component design to minimize the man hours in fixing the modules to the tracker. That's one of the benefits of an integrated module and tracker package. The minutiae of every last engineering detail has been rigorously engineered, including how the modules from Trina integrate into the tracker from Trina, and basically optimize performance and long-term reliability. Then we have our 2-portrait Vanguard. This has the modules in a 2-portrait configuration. It's what we call single row, so there's no mechanical linkages between the rows. So you have completely unimpeded vehicle trafficability between every row, which is great for construction, O&M, vegetation management. Also possibly unlocks co-location opportunities for solar and agriculture as well. We have optimized both of our trackers, specifically engineered them to accommodate these increasingly large modules, and really drilled down and value engineered from the wind tunnel testing to really reduce the number of foundations. So it can be as low as 100 foundations per megawatt peak. And again, we use the spherical bearings on this tracker to unlock sites with highly variable terrain. So basically, I'd said about the sites typically becoming constrained in terms of area. The form factor of our trackers are shorter north to south and wider east to west. And we see that typically unlocks a greater land utilization compared to skinnier and longer trackers. This either enables us to deploy more megawatts in the same area, or the same amount of megawatts, but at a wider pitch, reduce the shading losses and boost the energy accordingly. This is the spherical bearing that I was mentioning earlier. So you can see it's fully articulated in all 3 rotational degrees of freedom. split bearings, so it assists construction. You can see this 100 megawatt project in the United States there. The tracker is really capably traversing the peaks and troughs of the site without really requiring any significant civils works, cutting and grading and so forth, and avoiding that key construction risk. Really, the key risks that we see are certainly geotechnical, but we know that some EPCs have come a cropper on inadequacies in site surveying, and choosing a tracker technology that can mitigate that risk is a good point of cost saving, and makes the EPC sleep a lot easier at night, and hopefully that's reflected in their pricing and contingencies. So we just did a deep dive on the impact of the bus cost, where we combine these Trina Vertex low voltage modules onto the Trina trackers, and we've compared a one portrait tracker, which typically have more foundations per megawatt, in excess of 200, compared to the one portrait. The one portrait has over 200 compared to our two portrait, which has as few as 100. We've looked at the electrical balance of system savings, because with the Trina low voltage modules, they use larger cells. So per module, there's fewer cells, so the voltage is lower. So we can run longer strings, and basically anything in yellow here on the table drives a cost saving. So we're up at 38 modules in a string, and the conventional modules are down in the high 20s. So we're saving on combiner boxes, trenching, connectors, and so forth. Then we've compared the installation costs. So you can see actually there's a penalty for installing the two portrait tracker, because the sections are heavier, it's higher off the ground. There's also a penalty for module installation, because, to be honest with you, it is higher as well. So we want to paint the full and true picture here, but what we see is these penalties with the two portrait are more than recouped when we consider, if you look at this column here, the civils and grading costs, that's almost 1.5 cent recouped, and the pile installation, which is almost 1 cent. So all in all, we're saving the EPCs 2.7 cents per watt, which roughly makes up based on current turnkey pricing, in and around 2 to 3% capex reduction. So as I say, it's a truly integrated solution, and with the modules getting to a level now where they're almost 2.4 meters long, especially in two portrait, that chord width is almost 5 meters, right? You can come and take a look at our tracker, and when you stand next to them, they really are quite imposing structures. So not just the module length affects this, but also especially running the longer strings. The longer the structure north to south, the less stiff the structure, and the lower the natural frequency, the more propensity to incur second order dynamic effects like galloping, fluttering, and so forth. So it's super important to partner with a company that's applied all requisite due diligence in the wind tunnel testing, on full aeroelastic scope of testing, and so forth. This is how we get around the dynamic challenges on the two portraits. So like some of our counterparts in the industry, we use a multiple point drive system, a master drive in the middle that's motorized, and a slave arrangement at each end. That locks the structure along the north to south entirety of the structure. This is how even though the structures are super big and lower stiffness, this really locks the structure along the length, and means that we can deploy these trackers with the large modules in a completely unequivocally structurally fit for purpose fashion. In terms of O&M, it's very important to see what's happening on the ground. So we have a proprietary SCADA solution where you can dial in and see the status of every single tracker real time. And this can assist in diagnostics and triage prior to rolling to site, which is typically quite considerable in cost in high labor cost markets like Australia. We implement intelligent stowing strategies in high wind, obviously. Also, if the trackers lose communication to the weather station, they go to a protective stow position automatically. We can also put the trackers in maximum tilt automatically if there's hail events or even flooding. So it's a very autonomous system and well guarded against every eventuality in terms of operating condition. We utilize intelligent tracking machine learning functionality. So there's two components to this, especially when we use bifacial modules. We see a value stacking effect where you get more of a bifacial boost on a tracker than a fixed tilt through the merit of being higher off the ground and more widely spaced. There's more of this diffuse irradiance that can come in and around the structure, reflect off the ground and be collected on the underside of the module. However, that's counterintuitive where might sound counterintuitive. In heavy cloud cover, it's actually beneficial to put the modules flat and not continue to track. So our weather station includes not just the wind stations, but also the pyronometers to recognize these heavy cloud cover events and do that automatically. And then on sites that have irregular terrain, at the start and the end of the day, when the trackers start getting lower and lower in inclination, it's very, very difficult to avoid every instance of near shading in that operating mode. What we do is we apply a machine learning approach there. So the trackers self-learn how to deviate from their standard operating algorithm to avoid every instance of near shading. And we find when we overlay both of these benefits, it's been independently verified to increase the yield by an additional 3 to 8%. So when we consider trackers, especially in regions like Southeast Asia, where in Australia, the tracker benefit is usually in and around 20% more energy. Southeast Asia, that can erode down to 10 to 15%. And that makes that, to be frank, that does erode the value proposition, or has eroded the proposition of trackers with monofacial in the past. What we do now, where we take the opportunity to use this technology with trackers that you can't do with fixed tilt, we can restore that benefit of tracking back closer to that 20% number, where it's easier to get the project up. It's not just the technology, especially we're seeing in Asia, where fixed tilt is more prevalent and ubiquitous. There's a concern that trackers do have moving parts and they'll need a lot more O&M. That's why it's important to partner with a company with a solid deployment track record, rigorous vendor qualification policies and processes, and a demonstrable low failure rate in service. And we actually don't see much increase in O&M OPEX for trackers as compared to fixed tilt, especially when you can consider that actually things like vegetation management and cleaning can often be performed in a more cost-effective fashion than on a fixed tilt. But then in terms of every step of the project lifecycle, it's important to work with a company that can support the customers in pre-sales engineering, help them navigate through these uncertainties of making the switch from fixed tilt to tracking on the foundation design, on the topography surveys, sending people to the site to train the installers, and then along into commissioning. And then, in terms of O&M, if we're seeing our customers perceive a benefit where they buy the module and the tracker from a single entity, there's a single point of accountability in service. It avoids that finger pointing. If there are any shortcomings on performance or reliability, it's just, one company and one company's problem to fix. Trina was a bit of a shameless sales pitch here, but we were announced as the joint most bankable brand in the industry for the 6th consecutive year in a row. So we obviously have the bankability, the balance sheet of the Trina parent standing behind the tracker solution. So yeah, this really encapsulates the presentation today. It's more reliable technology, well proven. We make more energy and we lower the capex. So the numerator over the denominator there, that's how we deliver the lowest LCOE. Thank you very much. This is our McCain project out in Ballarat. We have a demonstration version of this tracker on our stand, and we'd be very pleased to talk to you further later on today. Thank you very much.
Thanks, Andrew. It's on. Okay. Thanks, Andrew. I was going to say we started late, but we've got a really long lunch break and keen to give the audience an opportunity to ask a question if there are any, because I think we've probably got time for one. I did put you on notice that I was going to look for for participation from the audience. So great.
Thanks, great presentation, Andrew. You got me. You nearly got a song out me there. Brendan Grant from Kleinfelder. Thanks for the presentation. That was excellent.
Pleasure.
Just wanted to ask a question about New Zealand, and you were talking about the piled embedment depth, about 3 to 4 meters. What's driving that?
I don't profess to be the expert on geotechnical or civils, but from what I understand, it's and that's the expert there. You can talk to him after, but as I understand it, it's the makeup of the prevailing soil there, predominantly volcanic and a lot of, a bit like Australia, right? Most of the population there lives around the coast, traditionally or typically cohesiveless soils, but lots of sand and silt rather than the kind of dense clays that we get usually inland. So that's why we have to go through that to anchor into something more substantive that can keep the tracker on the ground in these high winds. So.
Great. Well, thanks very much, Andrew, for your presentation today.
Thank you very much.
Thanks. Well, the room has really filled up, so I'm sure I'm not the only person really interested and excited to hear this next presentation as well. Now that I've known some of you for a few hours, I'll admit that before I was at KPMG, I was at AEMO for 3 years. And so I did see firsthand some of the large scale grid connection challenges that I know many of you will have faced with a lot of pain. But Darren, I'd love to invite you to the stage to welcome your panelists as we look to some of the grid challenges and around a presentation on tackling Australia's weak grid to unleash solar potentials.
It's actually me.
Oh, I'm sorry. Sorry, Dawson Tan, who's our moderator today.
Yeah, no worries.
Sorry, Dawson.
It's okay. Hope I don't let the team down. This one's going. I actually invite them up to sit and introduce themselves if possible, because I think honestly they themselves know themselves better than I do. Oh, and we've got Greg. Excellent. So just a couple of housekeeping things before we begin. I will be looking at my phone quite a lot, but I promise it's not to check the cricket or my share portfolio. It's for my notes. And unlike some of the other speakers, I also want to note that I think with the panels that we have, the perspectives that we've decided to take is probably more on the other end of the system, probably from the consumer, sort of residential, commercial, industrial end, as opposed to sort of the traditional generation end. Before I begin, I might just do a quick intro to myself. My name is Dawson Tan, Acting General Manager, Electricity Networks at Energy Networks Australia. For those of you who don't know us, we are the peak industry association for gas distribution, electricity distribution and transmission businesses in Australia. And our members provide approximately 16 million connections, energy solution connections in Australia, of which Greg is one of our members. So that plug out of the way, I'd like to invite Greg for a quick intro. Please tell us who you represent, what your focus area is, and a sense of the type of work that you do.
Yeah, thanks, Dawson. It looks a little bit uncanny to be there on the screen, so looking down over you. But yeah, my name's Greg Hannon. I'm the head of network strategy and non-network solutions for CitiPower, Powercore, and UE. So we're 3 of the 5 distributors in Victoria, representing 1.8 million customers. And so my portfolio is to look at driving innovative solutions within our business and trialing those and rapidly turning them to become BAU solutions. So yeah, my portfolio spans, where the future of the network and delivering trials and programs to help support that vision. And we've done a lot of work this year in deploying distribution connected battery programs. Thanks, Dawson.
Thank you very much, Greg. Stan.
Thanks, Dawson, and acknowledging my panel colleagues and the audience. Thanks, delighted to be here. I'm Stan Krapan, the CEO of Solar Victoria, which is a Victorian government agency here in the Department of Environment. Our focus is obviously residential solar. So we deliver the Victorian Government Solar Homes Program. We're 3 years into a 10-year, very ambitious $1.3 billion investment, which will see more than 750,000 Victorian households fitted with solar. We're at about 600,000 already. 175,000 of those have been funded by our program since 2018. So rapid uptake of solar. We've now expanded that portfolio to include hot water. So obviously the solar and energy efficient hot water, home heating and cooling to 250,000 low income households. through reverse cycle air conditioners and heat pumps, and batteries. There's about 18,500 batteries. Seeing really significant growth in the residential battery sector, which I'm happy to explore. But in terms of today's topic, which is about integrating with the grid, the batteries are a part of that, but there's also a significant investment, which I'm sure many of you are aware of, at least here in Victoria, $1.6 billion in last year's government stimulus budget towards a range of energy efficiency as well as storage solutions. So large scale storage, as you might have seen, Moorabool went active today, 300 megawatts of backup storage there, but also seeing the opportunities around orchestrating residential batteries through BPPs. So we're just about to announce next week, hopefully, 6 successful aggregators for our battery program, and a range of neighbourhood batteries and a whole range of things that I'm keen to explore today. So thanks, Dawson.
Awesome. Thank you very much. And last but certainly not least, Darren.
Thanks, Dawson. My name's Darren Gladman. I'm Director of Distributed Energy for the Clean Energy Council. Clean Energy Council represents a broad cross-section of the renewable energy industry. In terms of today's discussion, we represent transmission companies and most of the distribution companies, not all of them, but we also represent the traditional parts of the renewable energy industry, whether that's solar panel manufacturers, inverter manufacturers, retailers, small businesses, installers, etc. Our main role is to undertake advocacy on behalf of our members, representing their position to the likes of the AEMC, AEMO, the other market bodies, state and federal governments, and also to assist our members in navigating their way through various regulatory mazes.
And what mazes they are. Thank you very much, everyone. I think that's given, hopefully, some background to what we are, who we are, what we do. So it's a fairly intimate event. So I think we can probably be a little bit more casual in sort of how we address some of the questions and have some of the discussion. So imagine yourself at the Christmas barbecue talking about energy, as I'm sure we all do. So an easy one to start off with. What are some of the foremost challenges that you see and opportunities for the future grid? And how do you think we will meet them? Stan, I'd like you to answer first.
So first, I'd start with the opportunity, which is that people love solar. I think we're way past the point where people are doing an ROI or a cost-benefit analysis on residential solar. I just think it's normative now, where people look at it, they see it on somebody else's roof. They see, in Victoria at least, about a quarter of homes. That's across the state. But if you think in growth suburbs, which is where most of our work is, so think Tarneit, most popular suburb in Victoria and Melbourne for residential solar, Clyde North, Craigieburn. So basically out of west, out of southeast and out of north, you're talking about 1 in 2 homes now. And my view is that we're preparing for a future where solar is universal, particularly in new homes, in the same way that many of us have got the flashiest, whatever it is, stone bench, whatever's in vogue at the moment. That's what people want. I think people are heading that way towards batteries, but batteries are obviously still not quite commercial. But I think we've got to be preparing for that future. It's not that long ago that people would have said a 20% penetration rate is impossible. SA has obviously dispelled that myth, 40%. We're heading for that by 2025. So the challenge is really the rapidity, just how fast that's happening, and that it accelerates, and that it's, as many of you in the industry know, it's a lumpy ride. So, last year in the middle of the pandemic, we had our highest monthly take up in November, so under lockdown. So basically people were buying solar online. They couldn't have an installer come out to do the quote. They couldn't have it installed until about Feb, and they still wanted solar. This year, that hasn't happened. I'd love to understand people's insights about what that happens. So it's lumpy, so it becomes hard then to predict. I think the challenge is, how do we integrate that sort of level of penetration with fairly expensive grid storage, grid level storage, home battery storage, as well as that there are other moving pieces. So EVs are heading in the same direction, I think, and I think the world has spoken. Most governments around the world have been very clear. The Victorian government has set a 50% target by 2030. You look at the EU, they're saying there won't be any petrol cars going into the UK or most of the EU. I think that market has already moved. I think if you own a petrol station in 5 years, it'll be for club enthusiasts only, unless it's fitted with fast charging batteries. It'll be like Blockbuster Video, like we just won't even remember them. So for me, I think the complexity is that in a really open market that is moving rapidly, how do we make sure that the settings are right, particularly around bidirectional charging for EVs? Because the risk there is that while we're sort of stacking up these technologies, EVs could just, I don't want to say blow out of the water, it's mixing metaphors, but it could really add the level of generation that's required, particularly in peak hours. And I think part of the challenge is you want to shave the peak and sort of obviously increase charging in particular during the middle of the day to sort of balance out that duck curve. So that's complex and there's lots of moving pieces, but I'd be more interested in my colleagues' take on that. Yeah.
And on that point, obviously, Darren, you represent quite a large part of that supply chain. So any insights that you can share on that?
Oh, look, I agree with Stan's observation that there's a massive amount of momentum behind solar uptake now. It's not only popular, but the economics is in its favour, and that's what really is driving an incredible uptake. 3 gigawatts a year or more on rooftop solar, and then it goes up and down for utility scale depending on various grid connection issues and availability issues. So I think the challenge and the opportunity is we're moving into an era of an abundance of solar to the point where we're seeing South Australia generating more than 100% of its energy needs at some times from solar and exporting interstate. The challenge now is how do we best use that abundance of solar, which is going to be an economic opportunity, but also a necessity if we want to continue to have a grid that's able to absorb more and more solar generation. So how do we get more batteries on the networks is probably the most exciting opportunity ahead of us in the immediate term, whether that's batteries behind the meter in people's houses, or whether they're neighbourhood scale batteries connected to transformers, or whether they're big batteries, electric vehicles. It's probably going to be a combination of all of the above. And then, in years to follow, how do we take advantage of the opportunity of super cheap electricity from solar to move into exciting areas like the one that was announced this morning between Twiggy and AGL for the future of the Liddell Power Station site. I mean, it's amazing what sort of announcements we're hearing week after week these days. It's getting hard to keep up.
Oh, yeah, for sure. The political alerts are just blowing up my phone every time. Greg, I mean, obviously we've touched on a number of topics there. Solar Victoria uptake in these growth suburbs, the ubiquity of residential solar, EVs, grid connected storage. You've got quite a menu to choose from. I'll let you decide which ones you want to tackle.
Thanks, Dawson. Yeah, look, I think there's a lot of agreement based on the panel. So hopefully you apologies if you're looking for a lot of dissent, but Dan and Darren, especially just, our networks cover some of the fastest growing parts of Melbourne, particularly in Powercore in the western suburbs. And, Stan mentioned Tarneit. We're delighted to be building a neighbourhood battery there through the Neighbourhood Battery Initiative program. But, our view is that, our job is to enable the investment decisions that customers are making. And, their love affair with solar, I agree, shows no limits, particularly for new estates. And so, we do see concentrated pockets where large clusters of residential solar, there are some new challenges that we're working to solve. And we put a lot of effort into that because ultimately, if someone makes an investment in solar and they can't get that energy onto the grid, then we're all worse off for that because that energy has to come from somewhere else and ultimately requires other investment, which is going to end up being more expensive for the system. So that's the way we're approaching it. We see network as enablers of the future. We really, focusing on what our role is in that area. And in terms of batteries, and EVs, but batteries firstly, we see that, the load has always been distributed. The generation is now distributed and increasingly more so, and it follows that storage will also need to be distributed. So we see a really strong role for network connected storage all the way down to the LV. And in particular, when you can do that, you can value stack network constraint, and you're ultimately going to be deploying new technology to solve and provide more flexibility to manage the changing conditions on the grid. In terms of EVs, we sort of see the forecasts that are coming. Totally agree with the panel. Our net zero targets mean that we are going to have to electrify a lot of loads, in particular in transport. And the best thing we can do as an industry is make sure we're ahead of the curve on that, because we don't want that to compound our problems. We want to shape the direction of that and make sure enable customers' choices, and that instead of having to for example, if the load doubled, you don't want to see the investment have to double. You want to integrate that new load, really affordable way for all customers, so then everyone gets to get the benefits of that. So that's kind of the way we see the world. I mean, I think the challenge is the speed and pace of change. As everyone in the room would be aware, and online is frenetic and doesn't seem to be abating, but that also is creating a lot of excitement. And, I think the traditional lines around how the industry was structured are breaking down, but there's much more, collaboration that we're seeing between parties that maybe weren't so good at collaborating in the past. So I think that's a positive, and I think there's good alignment around in the industry about just trying to make it all work for the benefit of our customers.
Excellent. And I suppose while we're on the topic of community storage, residential storage, you as in Solar Victoria obviously has a subsidy program for residential storage, and you've got larger grid connected batteries connecting to the network now. Your government perspective, where do you see the role of storage at these various levels in 5, 10, 15 years?
It's obviously very important. As part of, as I mentioned, last year's budget, there were significant investments in both big batteries, so the largest in the Southern Hemisphere, as I said, open today, but there's a number of others, another one at AGL. I actually do really like that they're using old power stations to locate the batteries. It makes sense, in terms of those communities that have been so important to Victoria's energy in particular, but also if you think of the Hunter in New South Wales and elsewhere. So large-scale batteries, neighbourhood batteries, and I think that's really about enabling and empowering communities who I think all around the country have been mobilising for many years in a whole range of areas, not just renewable energy, but sustainability, climate change, and they are now, you look at Yakandanda wanting to be totally renewable, there's others, Newstead, a whole range of communities. The government has supported those through what are called community power hubs, which were started at Sustainability Victoria, where I started, which is a combination of energy efficiency, renewables, and then also storage. There's now 7 new ones, so 10 all up that have been funded. In terms of neighbourhood scale batteries, again, PowerCore is one of the, I think there were 16 projects, 3.6 million announced just a couple of months ago, all around the state again. And I think it's about a combination of, local empowerment, individuals. Some people will want to be able to control their own power and have their loads. We've been having a conversation with some of the DBs and also communities around standalone power, particularly for batteries and PV. Most people assume that they can just island and use all of their own power. Obviously, that's not the case. But raising awareness of that, particularly in bushfire affected or wind prone, storm prone communities. So I think it'll be a combination of all of those, and there's money being invested into all of them. In other parts of we're not unique, but I think we're pretty special in terms of what's happening. But if you look at for instance Hawaii or the east of America, Greg was talking about value stacking. There's actually separate tariffs to encourage community scale storage, which I think is something certainly worth exploring as well.
And Darren, your thoughts on sort of where storage in general, large or small, 5, 10, 15 years?
Oh, look, I think at least in the next year or so, the neighbourhood scale battery is the new thing to watch. So I think the big batteries will continue to be rolled out, and they'll continue to do what they're doing, and they're doing, you know, an awesome job. But I think I would say look at the places where the economics is right. You've got government support, the right regulatory framework, and the distribution networks behind it, and that's where you're going to see this neighbourhood scale battery initiative really roll out. So it's been established for a few years in WA, different set of rules, different system, much simpler than the national electricity market on various levels. And that has been quite a successful program so far. In the East Coast, you're seeing the most support, I would say, from, at the moment at least, from the Victorian government and the several Victorian DNSPs. And I would have thought that if we stick with our current policies and our current settings, then my expectation was that you would see things like the project at Corryong and Omeo and Mallacoota of an islandable microgrid with a community battery, but still connected to the network, but able to be de-energized during high fire risk days, etc., would be a really sensible model. And in addition, people perhaps in the AusNet services network who've been very adversely affected by fire and weather events recently would be showing an interest in standalone power systems. However, the other thing to really watch is what happens during the federal election, because Labor's committed to 400 community batteries. So we can expect those to be announced over the coming 3 months or so. I think half of them will be announced in the election campaign and half they'll save until if/when they get into government. And that will kind of turbocharge that part of the sector, I think. So that's something interesting to watch.
Thank you, Darren. And Greg, as the network that probably has some significant portion of that 400 community batteries, your thoughts?
Yeah, so I think certainly in the near term, we're really looking to deploy our pole-top batteries in the UE network. So we're planning to have 40 of those deployed in the next 2 years. And the first of those units will be going up next year. And, you know, that model is giving a lot of flexibility around location. It gets around some of the land access issues, but we'll be showcasing that. They're much smaller batteries. So you can only hang relatively small batteries on poles, but also with the neighbourhood batteries, yeah, we're definitely seeing a lot of momentum and enthusiasm from local communities. So we'll be looking to, you know, showcase the work we've done there, not only in our own battery, but working closely with the Yarra Energy Foundation. So we're really exploring the two models, where one where the network is the owner of the battery, another where it's a third party, and in this case, a community energy organisation. And if you look, look over the horizon, I think, storage is going to be needed and ubiquitous. It's going to be there to target those, really targeted LV constraints. It's going to be there supporting the grid, as you say, at a big battery level. But then I think, if you start looking 5, 10, 15 years ahead, we're going to start to see batteries doing more things. They'll be providing resilience potentially in different applications. You're going to start to see a few more grid forming inverter trials happening. And as we sort of look ahead, in the distant future, well, not distant, but maybe beyond 10 years, with much more levels of renewables, I think that grid forming mode is going to become even more and more important. And so I think you'll start to see some, momentary isolated applications, and then they'll be developed further for maybe some more permanent solutions. And I think the other thing to note is, like, storage is going to be needed, for short duration and long duration. And I think increasingly we're going to be talking more about longer duration storage as we progress towards net zero.
Awesome. Thank you, Greg. Bit of a curveball question, but it came up in sort of our email thread beforehand. Darren, you mentioned the problems of things like minimum demand and too much solar, and Stan mentioned, basically an optimization question of how we get that solar into batteries and then use it when we need it. Your thoughts on, if it were up to you, where would we, what kind of decisions we would do, and what kind of decisions should be made? Or considerations?
If it were up to me, I guess my wish would be that we get a sensible bipartisan energy and climate policy. What a dream, you know. But that would be my wish.
Yeah.
Look, I guess we've mostly been talking about it, the distribution scale, but I think also it's worth noting that we have significant issues with transmission connection, and the capacity of our transmission system is fairly limited, but also the model for financing that, say, is perhaps no longer fit for purpose. It's a well-developed model for incremental change in demand and meeting that demand, but it's not at all a good model for the transformative kind of times that we're in at the moment. So I was very pleased to see that the Federal Labor Party retained its $20 billion rewiring the nation commitment, because I think it kind of needs something more than just cost benefit analysis and the customer always paying to really bring up the transmission network to where I think it needs to be. So yeah, look, that'd probably be my big one. If we could have a bipartisan policy on strengthening the transmission grid and how to do it.
Yeah, awesome. And Stan, your thoughts?
If I could bring it down to a household level, I think where there's been a conversation, particularly over the last few months, around electrification of households. I think that will continue, and I'd really like a mature conversation about that. So that's my Christmas wish list.
Yep.
And a new pair of Kayanas for a run. But I think where I'd be keen, and I know Greg and others in the DB business are keen to talk, but I just haven't seen a lot of traction, and I'd like to, is we're investing, $300 million into 250,000 air conditioning units, basically. Now, they should be all running during the day, and they should be orchestrated and optimized. And I think at a grid level, at a distribution level, I'd want to have that conversation. How do we make that attractive? How do we optimize it and soak up some of that excess power during the day? I'm doing the same with hot water. So 60,000 efficient hot water units, heat pumps and solar. How do we orchestrate that? And whether it's DBs or whether it's aggregators, I'm really keen on that. And then at an individual household level, if they're going to be electric, they need to be more efficient. And in Victoria in particular, where we spend more than others on heating and on water, heating water, I'd want to make sure that that's both efficient and cheap. And that we, frankly, people aren't as interested in energy as we are. Like, I think that would be one thing less that people would be interested in, is not having to worry about an energy bill, but knowing that their house is modern, clean and efficient.
Yeah, definitely. Like, it ticks all the boxes almost. And yeah, definitely to Greg, I mean, electrification's mentioned, EVs mentioned, that seems to indicate a lot of potential network build, but there's also an optimization element to it as well. Your thoughts?
Yeah, I mean, because you're right, Dawson, all those things are definitely going to require new investment, but it's up to the industry to make sure that's done so that customers continue to have affordable energy that's safe and reliable and all those good things, and gives them the flexibility and choices they're looking for. So it's a slightly new paradigm, but I think, we can never lose sight of affordability. But I think, the worst thing that could happen is if the peaks were compounded, but we're all working to avoid that. And I think, Stan's comments just now about orchestration and, how can we be a bit more innovative with some of the loads and shift them around? It's definitely things we're looking at, and probably Stan, in the near future, I look forward to chatting a little bit further with you about that as well. But I think, if you look at basically the direction of the NEM, and certainly coming out of the ESB, it's all about up-down control of everything, basically, because we need that flexibility and minimum demand, peak demand, good examples of that. And I think we're all working to kind of find the solutions. And I think we just need to be pragmatic where we can, not sort of be held back by some of the kind of sacred cows of the past, to be honest, and just focus on what works, in particular for customers, because, the feedback we get is that, customers are, but, they rely on us to solve it for them as well. And I think that's good perspective. and we're all working really, really hard to make that happen. And in terms of, my Christmas wish list, I think it's just, a bit more pragmatism all around so that we can get on and trial things, make things happen, showcase them with the rest of the industry, and then learn from each other. I think that's a bit of a utopian vision, but more seriously, a 5-0 Ashes whitewash by the Aussies and a much better 2022 for everyone is probably my wish list as well.
Okay. If I could ask a question of you, Greg, because one of the issues that has been mentioned a couple of times is EVs are coming on. We've got to make sure they're charging at the right time so we don't add to peak and add to additional expenses. And I've heard different approaches proposed to that. One is the coordination piece, to be able to turn things on and off, up and down, dynamic operating envelopes, all that sort of business. Another approach that I've heard people talk about a lot is it's all about tariff reform. The economists like to talk about how it's all about pricing. But, frankly, I'm a little bit skeptical about that, because if you're accustomed to spending 80 or $100 to fill up your tank, and then you can charge it at a fraction of that, then does that difference in tariff, if you're paying 50% extra to fill your car when it's way cheaper than using petrol or diesel, are you really motivated by it? What is going to motivate customers is convenience and having the ability to charge their car in the middle of the day when we've got a glut of solar. It's going to be cheap energy, and it's going to be about practicality and convenience. What you see, are there any barriers to us being able to roll out enough of a charging network in the places where people need them at the times that people need them? And what changes do you think need to be made to speed up the transition?
Yeah, so I think touch on the first comment there, Darren. So, tariffs, whenever anyone comes to talk about any project, I just know this first or second order of business is the tariff, right? And obviously it sets often for the whole project. So, often people are looking for an exemption tariff since they're with the regs things, but that's not a sustainable solution more broad. And one of the other challenges, the tariffs are set for networks every 5 years. And of course, there's not many projects that have a 5-year payback at the moment. So there's a lot of uncertainty on that front, even though we expect that, arrangements that are in place now would continue for projects that span more than 5 years. So with, EVs and batteries, and let's face it, EVs are just a battery on wheels to some degree. What we need to see is the collaboration sort of horizontally. And I think where these things are going to take off is where there's value for the customer, there's value for the network, and value for the retailer. So if we can signal some of the best players putting charging solutions, and those who are looking to offer solutions will be guided by that. And then ultimately, the offerings that customers make, the offerings to customers, I think we're going to have to wait and see I can't tell you right now what customers are going to prefer, flexibility, and looking at how people do respond, because you help out. But if we took that approach to how we choose cars, we'd all be driving secondhand Toyota Corollas because they're the most efficient, right? And that's not the case, right? So that we do need to work out what the customers want and how they respond. And then I think provide that value across, I think is where we're going to find the answers. And I think in this time are being trialed today, and things are moving that quickly that we need to kind of get things right so that we have a stable framework for when these things become BAU, which, I think you both said is very near term.
And sort of just to bring it back almost to solar PV, because obviously we've been talking about electric vehicles. Solar PV has been around for, in a residential sense, for about at least 20 years in terms of common uptake. And are there any insights or lessons that we've learned from that 20-year experience that we can apply to electric vehicles or any future Stan.
Look, I don't have a perfect answer for you, but it seems to me what we learn is what we've learned in other domains as well. Australians love new technology. We're early adopters of technology when the price point is right and when we see others doing it. So if you think VCRs or DVDs or cable TV or mobile phones, very high uptake, almost universal. I think that's where we're heading with solar. So the job, and to be fair to Greg and his colleagues, I've been actually really delighted with the level of support that we've had from the DBs here to enable that, because I think they see it from their customers, and they know that their customers want to connect. And in the most recent AER approvals, 95% of customers in Victoria for new be connected, and Greg and his colleagues and others have invested in the grid in exactly the same places that I'm pouring money and solar panels into. So I think for me it's about that early adopters. So where are we heading? Let's plan for that, not resist or challenge or I think it's infamous now. People were saying nobody will want an EV, and that's just been blown out of the water. That's just not true. People will want it because it's clean, it's new, it's fantastic. It doesn't make any noise, and it's cheaper. It'll be, on average.
What can we learn from the last 20 years? I think one of the tragedies is that Australia in so many ways was leading. We had leading manufacturing facilities. We've led in develop some of the IP. We've got some of the best soldiers in the world, and we lost the industry, and it's not manufactured here. And I think that's a real shame. I think we have an opportunity with batteries that is way more significant than we had for solar, because we've got the same intelligent workforce, we've got the same economic opportunities to roll it out, but we also happen to be sitting on most of the world's deposits that you need for batteries. So honestly, if we cannot seize the opportunity out of manufacturing batteries and also making an industry out of the whole integration piece and making that a big export industry, I mean, that'd just be such a wasted opportunity.
Definitely.
Can I just say on that, Darren, as well, that it's also not just the hardware, it's the it's the software, it's the digitization. There's some amazing startup companies and scale up in Australia.
Yeah, absolutely.
And Greg?
Yeah, so general comments around, what can we learn? I think, look to the work that Stan's done with the Solar Homes program. I think distributors work really well with the government to sort of say what are the sort of inverter settings that standards and the like, because we could see that there was going to be massive deployment. And I think if we see the same for storage and for things like EVs, I think it's important that we as distributors and other industry stakeholders share those views early with government. And the opportunity around air conditioner control and so on is another example where if the government's deploying hundreds of thousands of new units, it would be a shame if the industry didn't sort of say, well, potentially this is what we would like you to consider as you do that, to give these options down the track. So I think that's the key thing. It's about looking ahead, not being reactive. I think the positive for me is that I think the net zero debate is sort of largely irrelevant. I think it's very clear in Victoria there's a legislated target. One way or another, it's probably going to be represented nationally. It is effectively at a state level anyway. It's just about how do we get on and achieve that over the next 30 years, and we've got to get cracking. So we're quite excited about it all. I guess the daunting bit is the speed and scale of the challenge, but I think it's all incumbent on all of us just to make sure we share our perspectives. And as I said earlier, let's not get held back by some of the sacred cows of the past. In particular, the industry model with large generator, large power lines, retailer customer in a linear arrangement. I don't think that applies anymore. And I think everything we're talking about here is, we've got to be pragmatic where the customer is at the center and everything else is organized around them. And where we need to share value, we should be able to do that, provided that, no one's getting ripped off. sort of the approach that we take, right? So I think that's, yeah, the 90s view of the world is probably something that's not as useful anymore. So hopefully we can kind of look to where it's going, focus on the customer, the more decentralized nature of the industry, and plan accordingly. That would be my hope.
Awesome. And also, just as a last question as well, this has come up in a conversation a few times now, this concept of decarbonization, decentralization, and digitization. What are your thoughts in terms of those three? What's the priority order ranking? And let's start with Darren.
So I've been working in solar for Clean Energy Council since 2012, just before getting prepared for Tony Abbott. And part of that preparation was don't mention climate. And we don't talk much about climate. It's like, it's a no-brainer. You use solar, it's good for the climate. That sort of comes with the territory. So we don't even talk about it that much because it just annoys conservative politicians when you do anyway. So we talk about the fact that it's cheaper, that customers want it, that there's job opportunities here. And so in terms of what you're talking about, I would say probably digitization is the priority now, because it's where that's kind of the mountain we have to climb. Like decarbonisation will follow and decentralisation is coming with the economics, but the digitisation needs to be done. We're not really in a position where we can say, well, let's just copy what Germany did, or let's see what Hawaii is doing, because places like South Australia are right on the forefront of this. So that's where I think the work is ahead for Australia, but that's also an opportunity for us when you're leading the world in something like that.
Yeah, awesome. Thank you, Darren. Actually, yeah, Stan.
Sorry, I probably agree. It is digitization. For me, the reason that I'd say that is because it's about optimizing the system, optimizing what is quite a different system. As Greg says, this isn't a linear system, which was optimized and which was as efficient as it could be, but unidirectional. We've now got something that's much more amorphous, that is complex, where people come in and out, and where it's obviously bidirectional, and digitization and optimization will be the key. The only way, in my view, that can succeed is if we recognize now that trust and transparency are going to be critical to its success, because when people are operating your appliances, they're exporting solar, switching it off when they need to, all of that, trust, transparency for the customer is going to be key.
It's almost like you're living in a house of someone else's appliances.
Yeah, well, exactly. And I mean, if you think just with your moan in early days, you couldn't read the bill. Everybody had a different bill. Everybody had a different tariff structure, and most of us distrusted it. Making the default the safer one that's in the customer's benefit, for me, is a key to some of these things.
And to you, Greg, I know all three of these things are probably hitting networks pretty.
Well, I think we take decentralization as a given, and almost decarbonisation as well. But I think digitalization is something that COVID, we've seen, has accelerated for every business, right? So when you make those investments, your business is always going to be better, even though, they can be challenging to deploy initially. So the way we're sort of approaching it is we see a world where we're going to have to coordinate and connect to, thousands of millions of devices eventually, and just effectively ensure that customers continue to have their safe, affordable, reliable energy and do the things they want to do with their own investments. And so I think the challenge for us, the way we see the world, is we're trying to define today what are the foundational building blocks of what the future system needs, try and clarify that, and then recognize that as we kind of move forward, we're going to have a bit of trial and error on the way through. And that applies not just at a business level, but almost at a system level. And so just trying to navigate and preserve some optionality, rather than just thinking that today we can build one system that's going to do it all for the next 20 years. I think that's a naivety. So it's challenging, but I think we just need to all have that in mind. As no one would have thought, if you look back 20 years ago, like where things would have got to today. I don't think there's any forecast that got that one right. And equally, to some degree, I think that will apply for the next 20 years. But we do know the direction of travel. And I think if we can recognize that, and I think as a network, we see a future where we're enabling, we're doing some of this ourselves, we're doing a lot of it with partnerships with others. I think the more that we can promote that, I think that's ultimately going to lower costs for all customers in the end. that's what our approach on these topics.
Great, fantastic. Thank you very much. I think we have some time now for audience questions. So yes, please. Oh, I think there's a microphone coming in.
Hi, my name's Rowan Huxtable. I work for T-Mike. My question's to the panel about an opportunity with all this community level batteries and islandable grids and things that's coming up, and that's an opportunity from standards for home and industrial scale inverters, because there's all this hardware being put in, you know, all these transistors and microprocessors, and there's an opportunity to make them so they can act as players in an orchestra, like they could be used for voltage control. The inverters you buy now, they're grid following inverters, but why not make it so that they could also, in certain circumstances, help to stabilize the frequency and be islandable. If there can be some sort of standards with inverters, then all this hardware that's being installed could be cost effectively used for these smart applications and being used smarter in virtual power plants later. So I'm just wondering, is there what's going on with driving smarter inverter standards?
That's a very timely question, because we're 10 days away from the commencement of a new standard, AS 4777.2 2020, which is killing the industry at the moment, just trying to make that deadline. It's really hard work. But what that will do is mean that distributed energy resources are more supportive of the grid, less likely to cause disturbances in responses to disturbances, and have more of a grid support role. I think the next cab off the rank after this current round of standards is progressed would be borrowing from what's called IEEE 2030.5, which is all about interoperability. So it's the ability of stuff to talk to stuff. So can my inverter talk to my meter? Can it talk to my fridge? Can my aggregator talk to my fridge? Do I want them to talk to my fridge? What is my car going to do? And then you mentioned grid forming inverters. There's a lot of interest in grid forming inverters as well. I think that will probably be the conversation that comes after the interoperability conversation. But this is all happening at once, so I don't want to make it sound like it's a linear thing.
We've used our settings in solar homes even before the standards were set. We work really closely with the CEC, the Smart Energy Council, and the industry to anticipate where technology is heading. We've got a technology guideline, and every year we issue a notice to market. We mandated smart inverters in 2019, so 2 years ahead of the standard coming in. And we're interested in exactly the sort of things that Darren is advocating for: interoperability. So whether you're in a VPP or at the end of your VPP, that you're able to set the standards, set the operating envelope for your inverter or your DB or your retailer are all part of that. And the disturbance, low voltage disturbance ride through is also part of our framework. It's a great point.
Greg, did you also want to add something?
Oh, I was just going to agree. It's definitely an important topic, and there's a lot of discussion in the industry. And you know, there's developments coming out of California and different things, and you know, sometimes tension between Australian and international standards. So definitely agree, it's an area of focus, and I can certainly share with the gentleman that it is something the industry is actively working on, and a lot of discussion about that, and in particular that IEEE 2030.5 protocol is one that we're looking to use for our battery projects, and we're hoping that will inform industry developments more broadly.
I'll also probably note that inverters are likely not only to be just used for solar, but potentially for vehicle to grid, vehicle to home applications as well. Yeah, next question. Yes.
We have seen this transition. I'm not sure it's working. Okay. the whole market in US or some other spaces are moving from F-gas battery to long storage batteries. And do you see that in future there are going to be communities which are like completely off grid? Means like what you're talking about, community storage means there are some examples in Western Australia and some remote regions. But do you see that more coming in? Other people or communities getting off grid, and how are we prepared for it?
Yes. Yeah. I think that's a resounding yes from all of us. Stan, do you want to kick us off?
Look, I think some communities want that resilience. So we're talking about the east of the state, but we see it in the north as well. Whether they want to disconnect altogether from the grid, I'd imagine that there are some, but I think most of them realise that being connected to the grid and the network has benefits as well.
And something that we've been pushing for about 5 years, and it's only now just getting to the point where it's made its way into the national electricity rules, is in remote areas, in fringe of grid areas, trials in WA have shown that it's more reliable, it's cheaper, it's safer, you get higher customer satisfaction. It ticks absolutely every box. It'll save the DNSPs money, and that can be returned to all customers in the form of savings. It's not a solution for everyone. I'm not suggesting that everyone should or will go off grid, but certainly in fringe of grid areas, it makes a lot of sense from every perspective. So we definitely expect that to start. It's still at the stage. Dawson, you might be able to help me with this. I thought it had got through into the national electricity laws, and we were now at the stage where we're waiting for jurisdictions to opt in. And I've been hassling jurisdictions to say, please opt in. And I've just got a letter back from Matt Keane in the last day saying, no, we're still waiting on the national electricity retail laws to change. It's like, oh, does this ever end? Is it ready to go yet?
I think the regulations are just a black hole in general. So
one thing after, you think we're ready to go, and then it's like, oh no, we've got to go off and change this one now.
This is probably more of a side conversation, but
Sorry,
I think there are some. There is some move by the regulator for ring fencing applications and sort of more bespoke kind of trial arrangements. But in terms of wider implementation, perhaps Greg can shed some more light on that.
I was just going to say, in terms of resilience and edge of grid, the comments so far, I think there's a bit of momentum on this topic. We've had people sort of who are wanting to talk about community batteries, also wanting to sort of see whether that battery can sort of, keep the lights on in a major outage. And we've sort of had to say that's not currently how they're being designed, but in the future, that could be the first step towards some kind of resilience or microgrid type project. This whole experience we've had in Victoria around the recent storms and so on, and this year in particular, has sort of accelerated, I guess, the thinking on that, and maybe the bushfires a couple of years ago as well. So we do see a potential where, people can have a solution at the edge of the grid. I think, costs are still challenging at the moment, but I think in the next 5 years, certainly, we'll see many more trials, and that will inform, how this can be deployed more widely. And of course, everyone's looking to WA because they have such a, sparsely populated state, much more dispersed than we have here in Victoria and on the East Coast. So I think they're basically looking to kind of phase out SWIR over time, over decades. So it's definitely happening, but I think to Stan's point, I think it's more, momentary sort of separation, longer term resilience, having the network there, I think is where we see it sort of emerging first.
Awesome. How are we doing for time?
Probably time for one more if everyone's happy. We've got a long lunch break coming, so.
Yeah, one more. Oh yeah, actually, yeah.
If I can ask one of Dawson and Greg predominantly, we've heard a bit about just the rapid pace of change that's happening in the sector. And then we have these 5-year regulatory reset cycles. The AER's just come out with its value of DER system. We're talking about community resilience, which is not valued by the AER. They think BCR is an equivalent. Do we have the right regulatory investment settings to enable networks to manage this transformation over the next decade?
Do you want the short answer or the long answer?
Short answer now, long answer over lunch.
I think no is the short answer. Greg, do you want to elaborate?
Well, I mean, you know, with the rapid pace of change, I think we are seeing the need for the regulations to evolve. And let's face it, the regulations are kind of there deliberately designed to be changed slowly. So there is some tension there. But if you look at what's happening in the UK, I think with their regulatory resets, you know, they're already starting to put forward their investment plans, are required to do so around what, you know, networks as a distribution system operator are going to look like. We see that future coming for ourselves as well. And we're looking to plan for that. And I think a lot of the insights from the UK will come across into Australia. But I think everyone's trying their best to manage the speed of the transition. It's inevitable that some of the regs will, you know, hold us back in some areas. But I think there's a commitment to outcomes and being pragmatic. I think ultimately, I don't think we never lose sight of the fact that, you know, we need to be as efficient as we can. But as we're sort of moving into this phase, it feels to me like a growth phase in terms of the investments we need to make and the new frontiers of technology we're having to integrate. I think we're going to maybe have to be directed by some other goals as well. And I think the other positive development that's happening on the regulatory front is much more and stronger voice of the customer. So, you know, eventually the proposals are being not just engaged with customers, but really almost being consulted on the way through. So I think that's going to be important as well. And I think that is being fed through into the regulatory process as well. So agree with the question. I think we're just going to have to muddle through as best we can, to be honest, but I think that is happening. And I think everyone recognises that to get to 2050, we can't do it based on the old settings, and we're going to have to be dynamic in how we move forward.
And I'll also sort of give a shout out, as it were, to the ESB, who's sort of tasked with, you know, developing things like essential system services and capacity markets and things like that. So, yeah, I think that brings us to the end of our session. I want to thank Stan, Darren, and Greg for their, you know, powerhouse insights. Always great to hear from you guys, and thank you very much for your attention.
Thanks, everyone.
Thanks to Dosan. We'll be back here at 2 to promptly get started again with what is going to be a packed afternoon. So thanks, everyone.